things. Yeah. So Lema. So Lema. Some people put doctor in front of it, Dr. Lema. So yeah, actually I hold a PhD in statistics. This I'm a statistician by training and also data scientist by certifications. So yeah, I'm a data scientist. I'm a data camp certified data scientist, and I'm also preparing others like DASCA. I don't know if you know about it. Yeah, so it, and I'm also taking the last one, which is the principal data scientist. I think this is the highest certification in data science. So I'm on it. So yeah, if you want to see my also my profile on data camp, you can do this profile and then Seknewna. Then if you type this, you are going to see, oh, data camp. Yes. Yeah, it's not coming, but okay. Anyway, if you Google me, you're going to find me, so no problem about that. So where do I work? I work at EMS. So EMS is African Institute for Mathematical Sciences as a researcher and lecturer. And through the partnership between EMS and the National Institute of Statistics, I'm working as a senior data scientist. So mainly my work is about capacity building. So you see, I'm still learning. You see, I'm still learning. If you go to my profile, Lema is still learning on daily basis. Okay, I'm still taking courses, doing certifications. Yeah, so it means that every day should be. You see, this is a certification I'm taking. It is getting expired every 2 years. So if you don't renew it, they will close it on you. So I'm left with the fifth step to get my data science certificate renewed on a data camp. So this is also a website. If you want to train, you have courses for free, and but it's very expensive if you need. Yeah, and I'm opening this because what we are doing here is on the same level of as what is being taught, in the United States and everywhere. So data camp is doing wonders. All right. So yeah, something else I want to give you is it's just like a guideline where everything will be coming from. So if you type R pubs and then Lema, this is something I already published. Ah, yes. I always forget. Sorry for this online people. So I was just showing my profile where I'm taking certifications. So as you can see, I have to complete this one in less than a month, and I'm left with the last steps. So yeah, so you need to just present your findings. There is a capstone project. The trainer is doing also capstone project online. So to be able to testify that I have this and that. So I also said that I'm also taking another certification. Oh, don't mind this one. Those are things I'm developing. Hmm? No, don't mind this one. This is a project I'm working on. Yeah. So DASCA is also a certification from the United States. So if you don't know about it, I'm not doing the advertisement of United States things, but just to tell you that those are the profiles that I will be holding soon, and I hold and be holding. All right. And last thing I was trying to mention is, the things we can cover, okay, in this session, from basic to complex. things. As Benon mentioned, you are going to go from the very basic for no people who did not use any programming language before or did not use R until we build dashboards based on data. Okay. The exciting part is dashboard. When you click here and then you see figures, things changing by district or by region, things like that. So if you go to your Google search, you can just enter or search R pubs. So R pubs is an environment created by our community to help you publish things you built, publish markdowns, publish books if you want. So now if you search, you are going to see the first link, which is things published by me. So and it's actually well structured so that you can start from here, okay, instead of displaying slides. So there is one here, it is published like 7 months ago. So R for data science. If you click on it, you are going to see something that will help us to start from. Okay. Yes. So yeah, if someone failed to install R, this is also an opportunity to do it. But I have to actualize this so that you get the latest version. So if you noticed, the one you have currently is 4.6.1. So I have to rerun the script so that this page gets updated with the new version of R. Okay. And at the end of the day, if time allows, you can be able to publish your own things like this. You can be able to publish also your dashboards. So I will show you how to do that, and I think it will be on the last days. Okay. Yeah. So I think we can start from 4. Yeah. So from the section 4, actually, like most of the R programming languages, R is a calculator. So if you have ever used a calculator in your life, then you have the necessary background to start this session. Donc, si vous avez une fois utilisé une calculatrice, so vous avez le background nécessaire pour commencer ce cours. Oui. Yeah. So yeah. So how do we even type the 1 + 1 and get 2 in R? You see, how can we start from 1 + 1 and then display a dashboard? I think people will be like, yeah, this is the very basic. This is the basics. So first of all, let's open our RStudio. So don't mind R. R is just working in the backend. And then we are going to open RStudio. RStudio will communicate with R. So anything you run in RStudio will be interpreted in R. And then you get the outputs in RStudio. So me, I have a shortcut here, down here. But if you want, on Windows, you just hit the Windows button. So you get something like this, a search button. In Mac, we have things like this. Okay, and then you search RStudio. Then if you see it, you can double click. Okay, and it's going to open RStudio for you. Okay. Don't know why it is dancing on. Nothing's happening. Oh, maybe yes, because I changed the version. So it is asking me whether I trust it. Sorry. Yes. Okay, don't mind this one. Those are the projects I'm working on. As you can see, this is the I was finishing my certification. So So this is what you get when you launch your R. All right. Let me also add some more things. I know people are not comfortable with the black screen or blue screen, so let me just take Chrome. Sure, this is what I'm going to do. 24 also. Yeah. Is it better? Hmm. Yeah. So if you want to like clean the console, this is what we call a console. So this is where everything is compiled. This is the console. So if you want to try the 1+1, it is done in the console here. So if you just do 1+1, so the console will interpret it as 2. So as I told you, R is just a calculator. So if you do 1 - 1, it will give you 0. Okay? Everything is running in the console like this. Okay, you do anything. 10 divided by 3, you have things 8 times 2. Yeah. Any operator you can think of works here. So you have to know which are the you have to know what exactly are the type of operators. I have already used plus, I will use minus, I use division is just forward slash, multiplication is star. Okay, what is the one left? I think, yeah, those are the main ones: plus, addition, subtraction, division, and multiplication. Okay, it's working, right? Yes. So we are not going to continue working in the console like this, because if you you write your own program, be it a function or a set of instructions, you are not going to copy and paste them in the console to have your work done. So we need what? We need a script. So we can create now a script file. Okay. So I also told you that we can also clean the console. So there is a broom here. You see it in the corner. There's a broom there. You can use it. If you click, all the console will disappear. Okay. But now one will ask, like, if I want to bring back I want to bring back all my commands after cleaning the space, you can just use the story function. So now nothing is working, but the story is somewhere here. So those are the things you already wrote: 1+1. So everything comes back. Okay, you can even export. Uh, you can send it back to the console like this, and then you'll see 1+1. Okay. Mm. No, no, click on one of the, no, click on the command, like 1+1. Click on 1+1. Yes, and then you send it to the console. Yeah, then you can still rerun it. So if you need, let's say 8 times 2, you can click on it and then send it to the console. Yeah, and then it can be still one by one. But I don't know if you can also click on, you can send everything like this. So shift, yeah, and then you send everything. Yeah, you can send all of them. Yes. So it's not only one by one. If you want to send things back like this, you can just use shift and the arrow down to select all your commands, and then you can send them back to the console, and everything will be running as you did. Okay. Yeah. So interacting with the console is just to tell you that everything you write as a function, as loading data, it passes through the console. Everything is compiled here. Okay.
What is console?
It's just a terminal. Have you ever seen this? This is how people were interacting with the computer back in the days. This is the console, or it is a terminal. Let me give you this is how people were creating even folders before. Can you look at, can you look at or let me open, yeah, from the console. I'm just giving you an example. If I want to access the desktop here, I can say, let me go to the desktop. So I'm now in the desktop. This is the console. So you interact with the computer using command lines. Yeah, and R also has this console, and R also has a terminal. Yes, and both of them, they work the same. This is like a terminal for R specifically, and the terminal up here is the one you interact with your current system directly. Okay. So people before were like making directories just by commands. Like I make directory when I'm in the console. I can call it R programming. And this is I'm making a directory, and this is the directory I'm going to use today. So if I click enter, and then you come back to what? To your, so you're going to see that folder created here. I wrote just a command, yeah, but I have the actual folder created. Just, yeah, this, I interacted with the console, and the console does something specific in your system. So this is how you should also understand it. A console is, is also like a terminal where you write things and then you see the results. Yeah. Okay, is that clear? Yeah, you can also call it an interpreter for that specific programming language. Okay, so now, how do we create now a script to send all the instructions in the console so that they get interpreted? So we have, if you go to the top left corner, you have just this plus, green plus. Okay, the top left of your R, you have that plus thing. Okay, you see it?
Yes.
If you click on it, you have many options. So the traditional scripting extension of R is the first one, and it is also very important. Okay, sometimes you may instead of using a package, you can write your custom functions, and then you import them in your if you are building maybe a report, R is also good for reporting. So everything you see here, notebook, it is helping you for reporting sake. Quarto presentation, you can create PowerPoints, actual PowerPoints from R directly. You do your analysis and then you import them directly into PowerPoint. And there you can also add a template so that you can be ready for your presentation anytime. Okay. Yeah, Quarto documents, you can create Word documents, you can create HTML documents, you can create PDFs directly from R. I will show you how. Okay. And now Markdown is the same as Notebook. So yeah, the four are almost the same because yeah. And the particularity of Quarto is that you can run both R and Python if you know both of them. You can import data with Python and use R commands to interact with the data if you want. If you are lost in R, you can use Python if you are more proficient in Python. Yeah. Now, how do we build dashboards? Is the Shiny Web. Okay. So you use Shiny Web now to build dashboards. Do you know what is a dashboard? For those who took Excel, with Excel and Power BI, we build dashboards where you have data in the backend and then you see graphics, tables. Yeah, you have slicers to filter data and so and so. Hmm? I do, I do. I have one published. For Yeah, this is a data entry and also data visualization dashboard I created for the Higher Education Council, where I was working as a consultant there. Yeah, they do have sensitive data, but I'm just going to show non-sensitive data. So this built from R. You see, you can have authentications so that your data is well protected, and so and so. So this is a dashboard. Okay. So you are dealing with. No, it's not this one. It's not actually this one. Let me go to. I have an unpublished version. This one is already being used, and let me take this one. So not. Yeah, this is my. Boom. Yeah, this is actually what we call a dashboard, and yeah, it is fetching data from the database. So takes like few minutes, few seconds to display things. Yeah, so they have a management system that counts the number of applications. So what is the number of people who applied through the Higher Education Council? And this year, how much do we have? From January till now, and yeah, the number of equivalences issued and the blah blah blah. So this is a dashboard. You just display key statistics. Okay. So yeah, as I told you, it is a bit sensitive. So number of acceptances and rejections. So we can be able to quantify them. Yeah. So this is what we call a dashboard, and you have even a more interactive one like this one. So instead of you displaying things that are fixed, you can even give the opportunity to the user to say, okay, I'm displaying things by gender. Okay, I don't have gender here. Maybe by application status. And instead of having like a pie chart up here, I need to have maybe a bar chart. Or if you don't want a bar chart, you want to have like maybe a pie chart. So it displays a pie chart. So it is dynamic. So the code behind is written in R. So you'll be able to do this. Yeah, you understand? So if you load data, you can be able to build a pie chart, a bar chart, anything, line dotted. It's up to you. Yeah. Okay. Hmm?
Do you have to do coding or you put that maybe that entity displays that?
You are the one instructing R to display this through coding.
Okay.
Yes, yes, yes. Yeah. Uh-huh. Yeah, yeah, yeah. You build it one time. If there is data coming in, you can still add, you can upload data if you want. If you have still data coming in, you upload data, it will merge it with existing data, and the displays will change automatically. Is that clear? Yes. So let me close it. This is a something this is for people. It's not mine. Okay. So now, how do we start a project from scratch, or how do we even? Yeah, I was planning things about those things. So the dashboard comes from this. Okay. And APIs. Do you know what is an API? It's application programming interface. So this where people can be sharing data from one system to another. Okay. And R also has that functionality. All right. Yes.
Maybe as a non-technician, let me say it's a way you create a channel for two different systems to
communicate. Yeah.
To operate together. You guys are familiar with EVM, right? Now, if I want to operate my business, if I want to start a business that sells POS, right? So there is a way you start a business that helps businesses to do their tax calculation for them. Like they deliver EPM receipt.
Yeah.
Now the business owner, the one who created the system, not the EPM, but the person who sells that service to boutiques and business owners, has to get an API from RRA that interacts with his system.
Yes.
Does it make sense? So it's a way two different systems or multiple systems can be able to talk to each other. So they use what they call API.
Yeah. Yeah. In addition to that, in Rwanda, there's something we want to do. It's not yet done. When you request data, people give you data into Excel files. Sometimes it is not even the version that they are currently using. Maybe in RBC, Rwanda Biotechnical Center, or MOH, Ministry of Health. They give you data into Excel files. But if you have APIs, you can just grant access to, interconnect all the institutions together, so that if I need data from NISR, I just go request it. It could be a button. I request for data about population or CRVS, or maybe population, or maybe there's also gender data lab, something like that. They have a lot of data sources, labor force data. They have it hosted there. You just have to click on a button, and then maybe the person in charge will just say grant. Then you can be able to see the data from NISR or from Rwanda Revenue Authority, and anything, and do your analysis if you are a researcher or any business analyst. Okay.
But should have also access it. If you invest, they should also reply to.
Yes.
If they don't reply,
you don't have. Yeah, but it is easy because sometimes what does it why does it delay always when you request for data? It can even take a year. We did a project between EMS and other institutions. For them to grant us data, it took 1 good year, and then we get dirty data, and then there is a cleaning process. As I told you, 80% of now AI is helping. 80% of time is about cleaning until you get now beautiful visualizations. And when I say AI, there's also a policy behind AI. You cannot just take any data and then throw it in AI. You are sharing data with who? You don't know. So there's also something you can share with AI. There's also things you don't share. We also have that AI part in this course. You can even build a dashboard with AI, but you have to know the code. If you don't know, then how are you going to run it? Yes, I can talk to Claude or GPT. I said, build for me a dashboard. This is my data structure. It will do it for you. Yeah, but if you don't know how to code in R, then you'll just look at the codes and how you'll use that. Yes. So yeah, let me not talk too much. So let's start our with our the simplest scripting file in R is the R script. Okay. So you can click on the first one. Yeah. So today we are going to cover R script and R markdown. Okay. So to be able to know R markdown, let's start with the R script, because R markdown is also like having, you'll be talking about chunks. If you have ever programmed in Python, it's like cells where you can write codes, and then when you are outside the code, you write as if you were in Word. So that you can write a code, see the result, and you can interpret even in the R markdown directly, and you can generate your report at the end of the day. Okay, let's start, guys. I know everyone in this world need actions. If you talk too much, people are going to say, okay, you are not here for your talking. All right. So this is an R script. Okay. And this is where we can also write, the things like addition. So addition in R is plus, right? So you can add any numbers, 65 plus or 67 plus 89 if you want. But how do we run this? How do we send this here? How do we send a command like this to the console? Yeah, they build, there is this button here called what? Run. Yeah. If you click on the run button, it is going to send now the instruction into the console, and then you see the result directly. Okay? Yeah. So if you want to also subtract things, so subtraction is just the minus or hyphen on your keyboard. So what is 12 minus 23? Yeah, it is a negative number, right? Minus 11. Yeah, and R knows how to do it. Okay. And
We start with a small letter, for example, subtraction. Can be also the result of.
Okay, that's a good question. So anything starting with hash or this one, yes, this one is a comment. It doesn't compile. So if I compile, if I click on that line and click run, what is running is line 2. Like comments do not compile. Hmm? You can write them in Rwanda. Amafaranga. This is the most used word in. Yeah. So yeah, coming back to your question, this is not a formula. It's just a comment. Yes, yes. You can put a small s or big S. It's up to you. Okay. Yeah. They taught us that any sentence should start with capital letter. This is why I'm doing it. Yeah. Okay, and then division or multiplication first. Multiplication, you have to use star. So I'm just typing things randomly. Okay. So this is multiplication. And now we have division. Division is just a forward slash. Looks like there's a question in the chat. Or
Actually, I have a question. Sorry.
yes, please.
And I know you just said this. What is the point of the
Yes.
words? Are you? I understand that you're teaching. What is the point of the words that you're writing? Like the literal subtraction, multiplication. What is the point of the words? Can you?
Those are comments.
So in this setting, you're just using it to show us. But if you did the mathematical things without the words, it would still run perfectly, right?
Yes.
Okay.
You mean if I remove all comments and run
Yes.
the operations? Yeah, they run. They run.
Okay.
Yeah, it's just to show people that if you want to divide, use. Yeah, it's not a formula actually. It's just comments. So to insert a comment, also there's a shortcut. If you want, you can use. If you are using Windows, it is Control and Shift. No, Control Shift C, I guess. Yeah, Control Shift C. That inserts like it inserts a hash like this so that you can start writing your comments. So if you are on one line like this, you can do Control Shift C. Then you can start writing your comment. Okay. Control Shift C. Control Shift C at the same time. Control, you hold it, Shift, and then C. Wow. Yeah, it's working. So if you have things already written like this, you can even comment them. If you don't want them to run, you can select all of them and you do Control Shift C. They all become comments. Now the question is, how do I go back if I want to uncomment? It's the same thing. Control Shift C. That's the uncomment. Comments and uncomments at the same time. Okay. Yes, please. Mm-hmm. Yeah, as I said, if you want to if you want to run your script, everything written here should be sent to the console for them to run. You know, they cannot just give you the answer directly in the script. Yeah, the instructions, those are instructions. They have to be sent in the console first. They get interpreted, and that's why you get results. All right, good. So yeah, we still have other operators. Okay, those ones are called arithmetic operators. Arithmetic operators. So let's now save our script, and I will show you why do we need scripts. So how do we save them? It's just Control S, as if you are saving a Word document or an Excel document. Control S. Yes. Now let's maybe go to desktop. Okay. And I'm going to use, if you don't have a folder already set for this, you can click on new folder. I know most of us have this functionality. You can click on new folder to say now data plus and then R programming. Hmm? Yeah, I'm creating a new folder. I'm also creating. Yes, I clicked on new folder, please. Yeah, sure. Let me undo everything. So I want to save this script, but I want also my script to be saved in a folder. So so to save is Control S, as in any application on your like if you're using Word, Microsoft Word, saving is Control S, right? So now you see this view. Now you choose where exactly you want to save your file. So be it in downloads, documents, anywhere. So I chose desktop, so that when I open my machine, I can or my computer, I can see everything. Okay. Now on the desktop, I have the possibility of creating a new folder. Okay. If you look, that view that is given, this prompt, if you look closely, you are going to see new folder. I don't know, for Windows users, it may be up here. Yes. So I click on the new folder, then I get also another prompt where I can write the name of my new folder. I can say data plus, okay, or maybe underscore or dash. Underscore is better because those dashes sometimes create issues. So data plus R programming, okay. Then you click on create, and your folder is now here. All right. Now you need to rename your file. Okay. If you want to rename your file, then the name basic, you can call it basic R.R. Okay. Don't forget to add the .R, otherwise I won't understand what you are doing. Okay. Or you can even call it sorry, R basics, things like this. So now the R script is saved, but as you can see, what is being showed here, I'm going to explain everything that is in this programming environment. Okay. You can see that those are my past projects I'm working on, but we want to bring the files we are creating here so that you see, as you create files or folders from R, you see things happening. But now it is a past project. You see, Now we are going to create an R project with this extension r.proj using the new folder we have just created. So how do we create now a project? And I will tell you why it is important to also have an r.proj, because you just have to click on it. You can close your machine and you come back, you just click on it. Everything you were working on, the data that was already imported, you don't have to redo it. It opens it directly. So how do we create a project? So you have the top right corner. Okay, top right corner, you click on the drop down. You are going to see, you can open an existing project, you can create a new one, you can close the current project, and so and so and so. Okay, so for us, we are going to create a new project. So top right corner like this, and we create a new project. So you are going to, you are going to see this prompt. It will say, okay, save whatever you are doing. You save it, and now you get also this additional prompt. So is it a new directory? No, right? Existing directory. So you click on an existing directory, and now you go and browse our existing directory. So go to, so it was on desktop. What is desktop? Desktop. And then data plus R programming. Yeah, and you can see that your file, your .r file is there. And you click open. Okay, let me repeat. So I go to the top right corner like this, click on the drop down, okay, and then I have the option to create a new project. Are we together? So I click on new project. R is going to ask me to close the current session. Then I would just say, okay, save it before you close. I can also decide to not save it. So save. Now you also get another prompt to show R whether it is a new directory you are going to create or an existing directory. And about control version, I'm not going to say anything now because you need to have a GitHub account. Do you know what is GitHub? You will know. Okay, but it is the starting point. We have so many things to cover. So existing directory, then we click on the browse, and now we look for what? For our folder we created. Okay, so it is in desktop and data plus R programming. If you click on it, you will have the option to open it. So if you see desktop data plus underscore R programming, then you can now finally click on what? Create the project. You see now what I was talking about. It is bringing your working directory with the file you created, and you have this data plus R programming. Why is it very important to have a project? Even if I close everything, I close the project, yeah, I close the project, I close R. Now if I go to my desktop and then open data plus R programming, I just have to sorry, where did I send it? I just have to click on this data plus the .r project to reopen everything. Okay, if you go to your file and then click on the the project file, the .r project. It's going to, if you double click, it's going to open RStudio, and everything that you were doing will be just loaded. If you loaded data, it will be there. Now the environment is empty because I have not run anything. If you have run things, your data you loaded, functions you created, everything will be listed in the environment. Okay, now you can see your files. There's no struggle about, I have to locate the working directory. I have to, no. It's already located. Okay. Now, you mean you can create a project on any, like anywhere in your working directory, working station? Yes. Yeah. Anywhere, be it in downloads, documents, not only desktop. Okay, you can create it even in a cloud if you want. If you're working like me, I have like, your cloud, I can put things in iCloud. If you want, I can put on OneDrive. Yeah, I have my personal OneDrive. I also have, I'm also consultant there. Please, United Nations. So yeah, you can also, all your OneDrives, if you want, you can put them there. So those are M's things, M's. Yeah, and personal one. You can save them there if you want. Yeah. Yes. So now we are all set. So if you click on our R basics from files, you see everything we wrote are there. If you come to files here and click on R basics, it will open it directly in the console like this, in the scripting part or source. Or maybe you cannot see the files. Oh, okay. Have you created the project? Not yet, I think so. Yeah. Where is it? Go click on. Yes. Desktop data analysis. This is where you should save it. Okay, can you double click on it? I think it is bringing other files. Can you go to your desktop? Click here. Yes, go to desktop or anywhere you want to. If you want, go to the data analysis. Do you want it to be on desktop? Yeah, data analysis. Create a folder here. Specifically for this one. New folder, and then our programming or something like that. Yes. Enter. Yes, close. Now, do you have the R script? You have it. Yeah, you can save that one in the. Click. Go to file, then save as. Yeah, then here our program. It was there. Go back here. Yes. Save. I can help him create the new project. New. New. First one. Existing. Open. Create. Good. Yeah. No, the first one. Yes. All right. So let me check something. Do you have your files displayed like this? You see R basics and also the .proj. If you have it, then check. But you don't have the yeah. So you just have to click on the .r to have it open like this. Yes. If you have those, then we are good to go. So why is the environment empty? Can someone answer that? Why is the environment empty? Yeah, we have run nothing. Nothing was run. That's why you have it empty. So if you click, if you click on this line, be it in the front or in the middle or after, and you click run, it will still be empty. It's not a matter of running something. It's because we have not created any variable. Yeah. So when you'll be creating variables, you will see the variables appearing here with their values. Okay. All right. So now let's continue with our operators. So we can still edit our file. So this one we can call it our operators, and the current ones are arithmetic operators. Okay, those are arithmetic operators. So you have the plus, you have minus, you have multiplication, and you have division. So there is also an operator we call what? Hmm? Do you know about modulus? What is modulus? For those who did a bit of maths. Yes? Square root and using modulus. Not quite. I don't know if there is a relationship, but it's just a reminder of division between two integers. Like if you divide a by a certain b, the modulus is the remainder of the division between a and b. All right. So if you have like a 10, modulus is this one. Modulus, for instance, let's say 7. What is the remainder of the division between 10 and 7? 3. Yeah. What is the remainder? Like when you divide 10 by 3. Huh? Yeah. So 10 has 7 one time. So if you deduct 7 from 10, then the remainder is 3. Hmm? Hmm? Let me use my Um, yeah, I was trying to write something, but now it is not writing. All right. I wanted to use my whiteboard to write, but now, hmm, you know, when you have 10 divided by 7 like this, hmm, how many? So, what will be the quotient here? So 1, right? So 1 times 7 is, so now 10 minus 7, yeah. So this modulus 10 modulus 7 will give you the 3, the remainder. Le reste de la division entre 10 et 7. C'est le reste. Hein? Modulus. Modulus, yes. Yes. Huh? Okay. One, if you want to like create, I saw the importance when I was teaching at EMS. Like I wanted to create a group of, like, now if I want to constitute groups so that you work on a mini project, the number, how many people do you have here? So I have 3, 6, 8 plus, I have 14. So if you have 14 people and you want to constitute a group of 3, how many people will be left without a group? Yes. So we have 2 people left without their groups. Now maybe you have 2 groups having 4 people. Yeah, this is the importance of having to know. Like you can have from 14 people, how many groups can you constitute? Yeah. So this is what is now bringing the integer division. The integer division now will give you the actual number of groups you can create. Like the group of 3 from 14 people. So now instead of having double percentage, you just put a slash in between. Now that one gives you the quotient. Okay.
In case you want to know the multiples.
Yeah, the multiple. Yes. So now from 14 people, we can constitute, you see, 4 groups of 3 people. You can constitute 4 groups of 3 people, but we have 2 people without a group. And now you can take the 2 now and say, okay, you can go to group 1, this one goes to group 4. So among those 4 groups, you'll have 2 groups having 4 people, and all other 2 groups having 3 people. So this is an application if you want. You have many applications around that, but this is the simplest one. So if you notice, I also can write a comment after running a script. So anything that is followed, preceded by hash doesn't run. So I can put it on top, I can put it after, but not before. If you put it before, then this part is not going to run. Okay, this cannot be before, like this part cannot be before hash. It will become automatically a comment. Is that clear? Is there anything that is not clear? Yes, please. Mhm. Because it is the remainder of the division between two integers.
That's the case for it to be false.
Uh-huh.
The case for modulus to be false.
The case?
Any case where you can run a modulus in the output is false.
No, that the reason to be the remainder in this case. So this is supposed to be the remainder, not supposed to be.
So, okay. It's Fabrice, right? Fabrice just said we are also checking whether 14 is a multiple of 3. So if it is a multiple of 3, then the remainder should be what? 0. So if it's not 0, then means that 14 is not a multiple of 3. Means that when you divide 14 by 3, there is a remainder. And this sign here gives you the remainder of the division. Let it be clear. Let me just... Yeah, it is something that you can use it later. So those who are online, they cannot see. Yes. So I'm struggling to make it seen, but let me do it here, and then I'll... So basically what we do is this. We have 14 people in the class, right? We are checking whether 14 is a multiple of 3. Yeah?
No.
Or we want to constitute a group of 3 people out of 14 people. So we say that we can have how many groups? Yeah, we can have 4. So 4 times 3 is 12. So we have to subtract 14, 12 from 14, and the remainder is... So this is where the 2 is coming from. This is what we call modulus in R. And this is the integer division. Is it clear now? Yes. So let me capture this. Hey, technology. Let me capture it like him. It is captured. I'm going to send it online now. Yeah, I'll send it later. Let's just continue. So the expected result here will be 2, right? Because it is a remainder. Huh? Yeah, sure. And the expected result here should be what? The actual number of groups, main groups, 4. Yes. Yes. Is it clear? So is 4 a multiple of 2? Hey. Why are you changing? Is 4 a multiple of 2?
Yes. No. Actors factors.
Yeah, so 4 is a multiple of 2 because 4 is 2 times 2. So not the remainder will be 0. Yes. So is 1024 a multiple of what? Of 5?
No.
Hmm? Not, yeah. You know, to be multiple of 5, the last number should be 0 or 5. Yes. Yeah. So you thank me later. I'm making you revise your mathematical. No. Yes. Hmm? Then we have also what we call an exponent or exponential or exponent. Okay. This is double, and this one is this stuck. Yeah. So exponential in R, you have 2 ways. There is this hat. So it's just shift and 6 on your keyboard, or you can have also double star. Double star is also exponent or exponential. So exponential, or it is also called power operator. So if you have like 2 to the power 10, so this how, if you want to raise 2 to the power 10, this is how we do. And this is 10,024, no, 1,024. Or you can also use 2 power 10. It's the same result. But when you will be using Python, please don't try this. In Python, this one means another thing, means XOR in Python, which is a logical operator. Okay, XOR. So using power, how do you calculate the square root of 9? If you want to use power operator to calculate the square root, eh? Yeah. So 9 power 0.5, 0.5, which is also power half, right? Hmm? Yeah, we'll give you the square root of 3, of 9, which is 3. So yes. Hmm? 9 to the power half. I put parentheses because if you remove the parentheses, it's not going to give you the 3. It is going to multiply 1 by 9 and then divide by 2. So parentheses are very, very important also in programming. Hmm?
So 9 is that, then you can bracket 1 divided by 2 is the same as 9 divided by.
It's the same as this. 9 to the power 0.5. Hmm?
Square root.
Yeah, is the square root.
Okay.
Yeah. How do you calculate the cubic root? Huh? 1 over 3. Yeah. Cubic root now will be, if you want 8 to the power 1 over 3. Should be 2. Hmm? I don't know. Why is it coming back? Why is the I'm afraid. So which is also equal to 2 to the power 3. Is it clear? Yeah. So 2 to the power 3. If you divide it by 3, it is 2.
So the power 3 is 8 divided by.
Hmm?
To the power 3 is 8
Uh-huh.
divided by 2 is 4.
No. We are talking about this one.
No, I'm talking about the statement.
Mm-hmm. So 8 is 2 times 2 times 2, or 2 to the power 3. So now if you have 2 to the power 3 like this,
It is 8.
uh-huh, power 1 over 3. Hmm? Let me show something. We have not yet reached uh, this, but I'm going to use the R markdown to write this so that you see the mathematics. Is it clear? Hmm? So this one is equal to what? 2 to the power 3 over 3, which at the end gives you 3. 2. Because 3 over 3 is 1, and a number raised to the power 1 is 1. Is the number. Yeah? Is it okay? Let me not bother you with mathematics, right? Okay. All right. So we have. Let me go on the up to check whether I covered all the operators. So we have division, modulus, and integer division. Yes, we covered all the arithmetic operators. All right. Now we are going to cover now what we call logical operators. So why do we need logical operators? This is where decision is coming from. You are going to instruct the machine. If you see this, if this is verified, then do this. If this condition is verified, do that. This is where uh, decision is coming from. Logic. Okay. So logical operators, as you see, as you saw. So we have the less than. So we have inequalities if you want. Inequalities, we have less than, we have greater than, we have less than or equal to, we have greater than or equal to, we have equal. Now, if it is equal down, now it will be equalities and inequalities. No, I'm mixing things up. So equality is this one. What are those? Less than or equal to? Inequality is difference, right? Okay, there's difference. I was looking for that word. Yeah. So you have all the logical operators. Then we will finish with the and or operators. So and is this, and or is forward slash, like vertical slash. Okay. So inequalities. Sorry, guys. So if I want to know whether a number is less than, just this, is 2 less than 4? What do we expect as, yeah, you have said it. The answer is true, and R is going to display true for you. If you want to check whether 2 is less than 4, the answer will be true in the console. I forgot one, which is not. Not is exclamation mark. Okay. So on the other hand, if you want to check whether 4 is less than 3, is 4 less than 3? So it's no. No means false, right? So 4 is never less than 3. Is 4 less than 4?
No,
Yeah.
it's equal.
A number can never be less than itself. Okay. Yeah. Now let's move to less than or equal to.
Sorry.
Yes,
Is
please.
there a difference? I'm giving 2 hashes and 3 hashes. It's
All of them are comments.
happening.
Yeah. Actually, the meaning of these hashes will be useful when you be in the markdown. Let me show you. If I copy this and then I go to markdown, actually in markdown, this is like the main title. This is a subtitle and subtitle. You can verify it here. You see the increment. Main title, sub, like in Word. Okay. Yeah. So less than or equal to. So is 4 less than or equal to 4? It's true,
Yes.
because here we have two statements. The first statement is we are checking whether 4 is less than itself, or 4 is equal to 4. This will become very, very easy to understand. So what does it mean? The first one, is it true?
Yes. Which one?
4 less than 4.
No, it's not true.
How about the second one?
No.
It's true. So we have discovered something. But if equal is 1, then we are now assigning it to a vector or to something. A single equal is assignment. Double equal is verification. Yes. Yeah. Sorry?
So is it the same as
Affectation. Affectation is French, affectation. Or assignment in English. Yes. Yeah. Good. Now we have discovered something that should be learned even down here, but now we have, if you have false or true, what is the result? It's true. So the OR operator just needs one statement to be true. Okay? Yes.
unless you use
Hmm?
unless you use instead of
Yeah, and wants both statements to be true. Mm-mm. If both of them are false, then it is false. Yeah, if you want to get through, then both verification should be true. Yeah. All right. What is remaining? Yeah, greater than. What am I writing? No, I'm finishing with these ones first. Then we come back to equal. Okay. Greater than. So denoted by what? This one is 1.8 greater than 2. Yes, no. I think both are not verified, right? Yeah. Is A less than B? So the verification is not only for numbers. Is A less than B? Why do you say no? Now here you see, look at the alphabetic order. So A is alphabet 1, B is alphabet 2. Is 1 less than 2? Yes. So A is less than B. Yeah. A is less than B. Now equality is I am learning R equal to I am learning R.
Is it on?
This is what I want to show you. Yeah, R is highly case sensitive. It is no, it's false. Yeah. So case sensitiveness. Yeah. So these variables are string variables. So R can handle various data types, strings, numbers, and also dates. Yeah. So strings should have quotation. Yes. Good. Are we together or? So normally at 11 we stretch for 5 minutes and then we come back. Can we do that?
Yeah.
According to the Minister of Health, every 2 hours you should stretch. If you are seated somewhere in the office or if you're working on your computer, every 2 hours you should stand up and stretch to prevent back pains.
So straight.
Yeah, we stretch for 5 minutes if you want to. If you want to stretch. And meanwhile, if someone has questions, you can walk around to help. So at 11 past 15, we can come back. Hmm. So, mon frère du Congo, l'anglais est encore limpide. Ça va? Ok. D'accord, d'accord. Ça marche. Ok.
Dr. Lema, can I ask a question?
Yes, please. Ask. Hmm.
Ok, je peux parler en français, c'est la partie des modulos là, j'ai pas bien compris.
À partir des modulos, ok. Ok, attends, je suis en train de connecter ma tablette pour que je puisse écrire là-dedans. Donne-moi
Ok.
une minute. Smaller is true. Yeah. Is 2 different from 2.0? Is there any difference between 2 and 2.0? Is it 2 different from 2.0? Yeah, there's no difference in R.
So the result is true. What's the result?
The result should be true.
It's saying false.
No, it's false because we said is it we are checking whether 2 is different from 2. Actually, they are equal. So 2 is equal to 2.0. Yeah, the result up here is true and down here is false. Actually, I didn't understand your question. You are right, eh? It's false. You're right. You're right. So, yeah, once we are done with operators, I want us to now open the R Markdown and start doing real things. Don't forget me.
These are runs.
Yeah, it's lunch. It's a sweet lunch. My lunch time is thank you very much. It's in less than 2 hours, yeah? 1.5. Okay, so we understood now the differences, equalities, inequalities, and now let's also use these operators that are used for combining two or more conditions. All right. Is there any question? No question. Okay. So you remember this, right? Is 4 less than or equal to 4? This is when we will be covering the OR operator. But end operator is denoted by the, we call it end sign or ampersand. Ampersand. So if you want, what is the English name of this symbol? It will tell you. Ampersand. Okay. It's called ampersand. All right. So if you sometimes you want to check whether you want to filter data. I want population from Bugesera, and that population should be having like at least primary level or they should have like university level. So you'll be using those a lot for data filtering, and yeah, just to verify some conditions, and data will be filtered accordingly. Okay. You can also use N on our toy examples, like is yeah, since we don't have like 2 columns, we can say is 2 less than or equal to 3, and also 2 is less than 10. It's true. Yeah.
Yes.
This one should be true because both conditions are true, right? So now let's try to change things. If we say greater, so this one becomes false, and combined with this one, what will we get? False. And if both of them are false, never. If both conditions are false, it is false. Eh? If both conditions combined are false, then the results using the AND operator, it should be false because none of them is verified, isn't it? Yeah. Using AND or it is always false. Which one? Yeah, if you want, you can combine it with the not if you want. So now you have to put the not like this before. Now it becomes true. Yes. So let's do a recap. So true and true gives what? Is true. So in R, T, capital T is true. You can even use true in full like this, or just capital T. They're the same. Okay. False and true is false. So this one should be true true and false is false. Why?
Because both of them are not accurate, and another one is correct, another one is not correct.
Yeah. And you can also use commutativity, tandem. If you turn like this, becomes this one. Yes. And then false and false is not true. Is false.
It's close.
Mhm. Yeah. So this is going to help a lot when we'll be interacting with commutativity. R doesn't know that word. Commutativity. So add it to the dictionary. Yeah. So even in multiplication, A times B is the same as B times A, right? So you can just commute. Is it commutate or commute? I don't know.
When it is false, it's not equal.
Come again?
When it is false, it's not equal.
I don't understand.
You are saying from that commutativity,
Yes.
A. So
Okay.
is it equal?
Okay. Let me consider that A and B are booleans, are true and falses. So A and B is the same as B and A. Is that clear? You just change the positions, swap positions between. If A and B are conditions. Then we move to the operator OR. The OR operator. So it's just vertical slash. Do you know where to find it? Yeah. It is above return or enter or entrée if you are using a French keyboard. So now, if you have two conditions which are true, so now if you combine them with the OR operator, is it true also? So if condition A is verified and B also verified, do we conclude that both?
True.
Yeah, it is true. Now, if one of them is verified, is it also true?
Yes.
Yeah, it's true. Commutativity holds also here. So now if both are not verified, it's false. Yeah. Now the last one, not operator. Can we run it on in our heads before we use the computer? Can we run this in our heads?
So true or false? Is it true
Where? True?
or false?
Yeah, it's true. Because one of them is verified. Because as you are saying, or if this one is verified, or the other one. So if at least one is true, then it is true. Huh? This one? Everything is false. This one. So who is seconding him? He's saying that it is false. Who agrees with that? Mind the parentheses also. So we have to finish with this block. Finish with this block before you combine it with the last one. Finish this one. And the last one is the not.
On that statement, the last one,
Mhm.
true or false?
Mhm.
Is it true?
This one?
No. The first one, true or false? Is it true?
Yes. True or false, it is true. Let me demonstrate it for you. 4 is less than or equal to 4.
Yes.
Yeah?
Yes.
What is the outcome of this?
True.
Yeah. And this is because this statement has two parts. We are checking whether 4 is strictly less than 4 or is 4 less than or equal to 4. No, it's 4 equal to 4. This single operator is meaning this strictly and then equality. So this one is what? False or true. False or true is true. It's exactly this. False or true is true. Isn't it? Mhm. So now let's go back to the exercise. So as I told you, parentheses are very important here. So you finish this block and go back. Huh? It's true. Now we have someone else is saying it is true. So what is, maybe we go for majority voting. Yeah, understanding the logic is very important. So now the highlighted one, we have is 2 less than or equal to 2.0.
Yes.
It's true. So it means that we'll be having this true and now how about this one? Yeah.
I had
Huh?
10 what?
10 modulus 2. What is 10 modulus 2? Is 0. So 0 is 0 equal to 1? No, then it is false.
Sorry, 10 modules. What does it mean to explain it?
It means we are checking whether the remainder of the division between 10 and 2 is equal to 1.
The remainder is 1. It's not 1.
It's not 1. It's 0. If you highlight 10 modulus 2 and then you click, you do control enter, it's 0. 10 modulus 2 can never be equal to 1. So it is false. Okay? Now this is where the parenthesis ends, right? And now we have the OR operator. Now the last statement here is what? Is 1 greater than or equal to 1.5? It's false. So what is the result of this? So false and false. False or false is false. Yeah, it's true. No, false. No, false and false is false. False or false is false.
False or false is false.
Yeah, it's here.
I think all, not
Huh?
all.
Yeah, false or false is false. Because none of the two verifications is holding. So it is false. It's true. So the lady has won the competition, the hackathon. Yes. Yeah. Let me share 2 sweets with you. Hmm? Yeah, so it's not false, it's true. Yeah. Yeah, for online people, I don't know how I can send you my sweets. Huh? So yeah, if you run also here, it is the same thing. So basically, we have covered all operators. We still have operators. There's this one which is, but we have not yet discovered what is a vector. You can, there is this in operator. You know, this is also an operator, but it will come later. If you want to check whether something is in, yeah, in a bunch of, yeah. For example, if you want is 1 in, you know, now you don't know what is a vector in 2. So this is how we define a vector in yeah, I want to complicate things always. This is just 1, but I write it as 10 modulus 3. So
The
is
element is one.
yeah, this one actually. Yeah. So if I remove this one, we are checking whether one is in this vector of numbers. So if you run it, it holds true because this is one. Yes. Mm-hmm. Yeah, I want to be always like hiding things. 10 modulus 3 is 1. So 1 is in this vector. Okay. Let me bring another tip. Is 1 in this vector? Who said yes?
No, no,
Where is 1 here?
no. Yes.
But she's right. True is 1. True is 1.
True is one.
Yes. True is 1 because if you say 1 and 1, it's true. And what is false? Yeah, 0 and 1 is false because 0 is false and 1 is true. I don't know who invented this, but I don't know what that guy smoked that day. Yeah. So logically, true is 1 in terms of number. And actually, when it comes to vectors, if you run this in R, you don't see true. R is converting because this is number. R will convert everything into numbers. So this vector is 2, 4, 6, 1. That's why 1 is still in that group. Okay. So don't mind this last operator. We are going to discover it. We have already discovered it, but we'll work more with it when we interact with data, real data. Okay. All right. So I want to close this script, not close it, but save and introduce you to what we call an R markdown. And I will tell you why it is very, very important. R markdown. So you go back to the plus sign, okay? And now we are going to select R markdown instead of R script. Yes, R markdown. Yes. So you go to plus go to the top left corner and you see the plus sign with the sheet, blank sheet behind. Oh, you don't have it? You should have it. Yeah. Click yes. You do updates. So whatever I ask you, respond by yes. So it is not installed. So it's going to install it for you. So if I ask you to install anything, after installation you get this. Confirm if you got that. Okay. So for the moment, don't choose PDF because it will not run. Choose HTML or Word. For the PDF one, I will show you how to install additional things, packages. Okay. Yeah, HTML. If you want, you can choose Word or Word. Yes. So now, yeah, it is. This prompt is asking you to give a title. So what I can call for data analytics and the dashboarding. Okay, and the author, you can put your name as you want. Yeah, I have Chinese names, very difficult to pronounce. Seknewna. Yeah.
Very Chinese.
Yeah. Yes. So for now, we choose document. Later on, we can also start from presentations or even Shiny using R Markdown directly. Okay. Or from a template if you have a template saved somewhere. But for simplicity, let's just consider document for today. Okay. And I don't want you to choose PDF because it is interacting with LaTeX. You see? Do you know what is LaTeX or LaTeX? You don't know? Yeah. So if you click OK now, you know this heading will be formatted automatically. And R is trying also to capture the today's date. So this thing is very important. When you do backtick R, and then you can write an R code that will be working. You know, it will bring the date of system date. So this is how automation starts. You can make you can compute a number and then use that R to put it in a wording. So if you change something, it will change also. Okay. How is it different? It's fine. It's fine. Yeah. It's very fine, but I know why it is different. There's something you didn't tick. You had to tick something. Use current date like this.
Can I go back and read?
Yeah. You can delete what you had.
I'll go back.
Plus the plus top left corner, and then markdown, and you tick this. Use current date when rendering the document. Good. Are you set? Okay, you're still writing. Good. Is it good? Can you see this now? Good. Yeah. So actually, when you define your first document, R gives you, it's just like when you buy a medicine from a pharmacy. They always write things, posology, you should get it. If you are pregnant, don't get it, don't take it, blah blah blah. This is how R is giving you like things you should read and then be able to run things by yourself. So when you want to like compile the document, you click on the neat button. So it's somewhere here. Okay. And since you said it is a HTML document, then you just have to click on it. Okay. If you want to change the document display or document format, now you can choose neat Word, but PDF don't choose for now. Okay. Yeah.
Neat Word.
Hmm?
It is neat Word.
No, it is by default. From your setup. You said, yeah, HTML. Yeah. So now if you click neat, you see, it is asking us to save the document. So it's the same. We are in our current working directory where our project is defined. So now you can give it a name, R basics, right? So it's not going to override the first one because they don't have the same extension, right? I can still call it R basics, but now the extension is RMD. The first one was just .r. Then you click on save. You see, R has constructed directly an an HTML file for you. Sorry, are you lost? So yeah, you just click on neat. But if it is your first time clicking on neat, it is going to tell you to save it. Have you saved? Okay. R basics, and then you leave the extension. You should not, remove the extension. So you have to add the extension .rmd, capital R and MD M and D are not capital.
Not capital.
Yes.
No.
Yes. R is capital, but MD are not. Yes. Save. Yes. Yeah, but you deleted it from there, so it's just save. Yeah. No, it's okay. You can now save. Yeah, this is the final document. Good. Yeah, let's change it into Word if you want. Let's change, instead of HTML, let's change it into a Word document. Yeah, instead of clicking directly on the neat, you click now on the neat option. So there's an arrow down black button there. Then choose Word now. So the same thing is being displayed in a Word document. Yeah, and this one is editable. If you are done, you can still give it to your boss or your collaborator, they can still add comments. They can say, okay, for this one, maybe the other comment, change this into that. So now we are in Word. So these are good news. If you are able to do analysis and then bring them directly into a Word document, you see how useful it is. It's huge. So now we are going to use this facility to generate automated what? Reports. Yes. So I'm not going to save. Now those are just examples given by R. Okay. So as you can see, this is a section. All right. This is a section, and this is the main title. So you have the author name, and then you have the system date. You can still add more options. If you want table of contents, blah blah, you can still add them. Okay. And this is a section. If you want to add a subsection, you know, add an extra hash. So you can say setup. So if you see the timeline, you see our setup is, indented. So the main one is R Markdown, and then comes our setup, and then you have also another one, another section, and so and so. Sorry? Yeah. You see outline here? Outline. If you want to see your outline, you click on outline. If you click again, it disappears. If you click, comes back, click again, it disappears. And also remind me, we are going also to connect AI to R later on when we master things. So AI will be writing codes for you. And we don't care if you use it for your capstone project or not. No, you are going to connect AI to the R Markdown later on, so that you can complete your capstone projects very fast. And Rwanda is open to AI. Who am I to to say don't use AI for your capstone project? Right? Or who are we as Data Plus? So are we all set? So since we know how to write sections, subsections, subsections, sub. So the more you have is called sub. So you can define your level of, or your depth of. So this one thing. You can also include links. Okay. So you notice that when you need HTML or Word document, you get a clickable link. So when you click, it takes you to your browser, and it is a working link. So if you want to, for instance, in your report, send someone to a certain web, you can copy the web, the URL, and then come back to R and put it, in the less than and greater than. This is how you, but it is not the logical operator. Okay. All right. So this one thing. So you can so now cars is an inbuilt data. When you install R, it is already in there. And the beauty in R, Python users, please forgive me for that. In Python, you cannot highlight like this and then do Control Enter and something runs. So R has it. This is the reason why you guys should learn R. It's very flexible. So this summary can give you the summary of, the two columns you saw. So mean first, yeah, we'll see it later. just to tell you that this could be included in the report, okay? And you can also include plots, yeah? If you click here, you know, that plot is coming. This is how we, you know, there's a play button. So it means that anything you wrote here can be included in a chunk. So what is a chunk? Is this one. A chunk is this delimitation. You see this and closed by this. So actually those options are not so necessary, okay? Echo is false means what? In the report, don't display the code that produces the graph. So in the report, you will just see the graph. So if you say echo is true, it is true by default, means that the code and the graph will be displayed. But if you say echo false, means that only the graphic will be included, which is also very useful, right? No one needs a code in a report. Yeah, you cannot send the report to your boss or your collaborator and say, check, this is the code that produced. I don't care. I just want to see results as a boss or as someone who wants to take decision, right? Yeah. So the use of equal false is very, very important in automated reporting. Just to demonstrate, if you turn it into true, you are going to see that both code, yeah, code is here, and the output are displayed. All right. So we are going to interact with options a lot here, but by default, this is how a chunk should look like. So backtick 3 times, and then curly bracket R. So here it is not case sensitive. If it is a big or small R doesn't care. It's still running. Okay. Yeah. So how do we insert a new chunk? So before that, I'm going to ask you to delete everything that is after this setup. So don't touch the setup, okay? So highlight from the section R Markdown till the end and delete it. We are going to start afresh. Like our document should be what we want to be displayed. From after this chunk. Don't delete the closing. If you delete them, nothing is going to run. Should start by this and be closed by triple backticks. So this is where you should delete. You see the setup, right? You leave it there and you scroll down from R Markdown here, from the title R Markdown. You click and select until the end, and then you delete. Good. Is it good? Okay. Now we are going to import all the codes we wrote in our previous file here in the R Markdown. So we are going to say operators. So all the codes that we wrote over there will be transferred directly using just a single command. Okay. So how do we insert a new chunk? you have this C up here plus C. So when you click on it, you are going to discover things. Okay, you can insert an R chunk. You can also insert what? A Python, if you know how to code in Python. Julia, if you know, if you know Bash. Bash is Linux scripting. I started this morning writing some like make a directory. Those are Bash commands. Even SQL, if you want to interact with your SQL server, you can still do it in R. Stan is those who are doing Bayesian things. It's very complicated. I don't like anything related to Bayesian. I use it, but I have to Google a lot. Yeah. Graph-wise, I don't know about it. Mermaid, I don't know. But still, I will learn. Before we were not seeing these ones, those two. I don't know what is Mermaid. Yeah. Yeah. Sometimes you see also D3, so and so. So now our interest is just R, so you just click on, So before you insert, you have to know where exactly you want to insert. It is when the cursor is under operator. So if you don't want to use that button up there, there's a shortcut also. You can use Control, Shift, and what? And M. I guess no, not that one. And I, yeah. Control Shift. No, it's Alt. Alt Shift I. It's not working for me. No, it's Control Alt I. Alt. Control Alt and I at the same time. Yeah. So to insert a new chunk, use the combination Control plus Alt and plus I. The backticks gives you, a very styled way of displaying things. So if you want to bring things from a script, from our script that we wrote earlier, the R_basic.R. If you want to bring, you want to like compile everything at once. Okay, it's like highlighting everything from that script and run them in this chunk. You just have to use the function source. Okay, so you source now from an external script. Instead of copying and pasting everything in this chunk, you just source. Okay, so when you source, use now you have to provide the link to that file. Okay, so once you open the two quotation signs, use the tab, the tabulation. You know what is tabulation? Tabulation touch or button. You are going to see every file that is in the working directory, and then you select the one that you want to access. Have you wrote the sort function, sourcing? The extension .r. This one, the one. Yeah. Double click. Yes. So you have linked the file to be sourced in our current Yeah. So now if you knit it, you will see. Hey, it's not displaying. What's wrong? Okay, let me run it here first. So if I run, oh yeah, nothing is happening. Hmm? Yeah, echo is equal to true. Yes. So you have to add the option echo is equal to true so that it can echo. Echo means make it, make the sound. But in programming, echo is meaning like display everything. Yeah. So if I knit it in the rendered file, you are going to see every command we wrote up there. Hmm? Hmm? Mm-hmm. So that source function has many options, and when you highlight, it gives you it gives you like the one I just saw here. It's saying print evals. Let me try this one too. I'm trying something. Yeah, it doesn't change anything. So let's just maintain this, just to tell you that you can also source from an existing script. Imagine that you wrote a function and then you saved it in .r. You can see source it so that it can get activated in the environment. Okay. Yes, please. No. Those, don't mix. This is the link. Let me repeat. So quotation, use tab to bring all existing files, the link to the existing files in the working directory, right? So I'm going to choose the .r file. Now I have to, I'm providing the link to the file to be sourced, right? So get out of the string and then put the comma after the closing quotation sign. So don't put the comma inside here. Okay? You have to be outside. Yeah, echo is equal now to true. Sorry? I don't get it. Yeah. So this is actually a parameter of the function. I will show you how to write custom functions in R. So this is one of the parameters in this for this source function. If you put comma and tab, you are going to see extra things you could ask R to include. So those are parameters that are needed for our function to work properly. Okay. So keep source. Let me try that one also. Okay, this is what I wanted. This is the one I wanted. So keep source true. So if you render, I think even the comments, even comments should be appearing. Yes. This is exactly what I wanted. So let me make something clear, okay? This delimiter here, triple back ticks, followed by curly R in curly brackets, and closed. Only codes should be written in between. If you write anything else like I am learning R, R is going to get lost because R will try to understand what is I. R will consider I as a variable. But if it is not defined in the environment, then you are going to get an error. So try to compile. It is altered. So don't write, if you are going to maybe interpret something, you have to write it outside the backtick, outside the closing backtick. So you write here.
And still, if you want to add another source of
Chunk.
code,
Yeah, you just
you have
go to a new line. Yeah, Control Alt I, and then if you want, you comment. Control Shift C, so your code goes here. Yeah, and so and so. So you can, yeah.
about source.
Hmm.
If you have a file from another folder,
Mm-hmm.
how to be called?
So now you are taking me to how do we import data in R? It will come tomorrow. Eh? We are, no. Sourcing is compiling, compiling a source code which is in another file.
But it's the same.
Yeah, it's the same approach. Now, if you have now a folder here with data, you can also import that data in the environment and you, yeah, but it's not today.
Oh,
You are ahead of time. It could be today, but it depends on the pace, how fast we'll be moving. But we are not on the same, always on the same page. Yes. Yeah. Yeah. You know, every day it will get better and complicated. Hmm? So sometimes you need to, you know, you don't want to see the display. If you want to save the space, you can just remove the output by clicking on this. You can clear it like this, okay? Be it a plot or a summary table, everything. So how do we insert bullet points in R Markdown? Let's say you want to explain what keep source does. This is how we insert a bullet point. Just put star after the chunk. This is a bullet point. And if you want to emphasize or make it appear as a code, you can highlight and then use the backtick, so it will open and close. Let me repeat. If you want to put a wording, a certain wording in backtick, so that it appears as a code or verbatim, this is how we call it in programming language, a verbatim. You highlight it like this, and then you use the backtick. Backtick is the touch that is before one. This is the backtick. Here's the backtick.
this one.
Yeah. So if you highlight the that you highlight, and then you can use the backtick, it will open and close at the same time.
You're right.
Yeah,
That's right.
you're right. Yeah. So star, you see the star, but when you knit the file, it will be a bullet point. This is actually a bullet point. And then I can copy this if I want to explain what this does in the code. I copy this. Okay. And then I can highlight and use the backtick to give it just a verbatim looking, So I can say, okay, displays codes and comments as from the original file. Okay. Then if you need another bullet point, so this one displays comments, codes, and results. And echo only is equal to true. Displays what? Code and results. Yeah, just an example. So if you need this one, instead of star, you are going to get bullet points. Okay. You see? Can you see? Lunchtime? Oh, no, not yet. So if you are together, are we all together? Where are you lost? Okay, you are writing. So you are not lost. We just have to give you some time to finish. Don't know why. So let's add a new section with double hash. So we are going to call it variables and data types.
Hello? Hang on, sorry. Can you guys see my questions in the box?
I think the best way is to open your microphone and talk directly, because it's
Oh, I see.
a little bit,
Anyway,
yeah.
so I just asked, I think I kind of got lost at the echo equals true up. Could you just please re-explain what that is?
Sure, I can, yeah. So the echo equals true, or false. Let me explain it here. So if I write echo is false, and now I want to do the summary of the data that is called cars. Okay. So when I say echo is false, means that this code is not going to appear, but the output will be rendered. So let's find out. Let me click on it. So because I said echo is false, only the output is displayed, but not the code. Now, if I say echo is true, it is true by default. After rendering, you are going to see that now the code is appearing. Is it clear? It's just a matter of displaying the code or not. Yes.
Okay.
So we are adding now a new section to our document, which is variables and data types. All right. So if you go to my web page here, I also have it there. So yeah, I named it R objects and assignments. So it's the same actually. Okay. Sorry. So what is a variable actually? If I'm if someone asks you what is a variable in a programming framework, what could be a variable? Okay, let's start by data type first. What is data type? Hmm. So data types, we already dealt with, I think, 3 of them already, even 4. So data types are, so we have what we call, we know about integers, right? What else do you know about data type? Sorry? Numeric. So integer is also numeric. So if you want to differentiate decimals from integers, so we have doubles. Yeah. Doubles is also float. Doubles is the same as, float. Yeah. So strings, so character variables. Then what else? Boolean, true and falses. What else? Dates. It's also a data type. What is missing? We also have complex data type. You are not going to, I'm not going to stress you with complex numbers. You have many. You have another one called row. This, if you want to encode a message, you can you can encrypt it and then send. On the other end, someone can decrypt and be able to read it. Yeah. What did I miss? Integers. So someone said numeric. So they are doubles or floats. So character, Boolean, dates, complex. I don't know if I think, let me check from my notes. Data types. So double, integer, and that's it. Character. Logical, yeah. This. Yes, there is also the logical ones. No. Factors. Logical is Boolean. And we have factors. This one is to deal with categorical variables. So to make R understand that this is a categorical variable. Otherwise, it is just a string for R. And it is hard to get a summary of it when you use the summary function, if it is not converted into a factor. Okay. So the last two, we are not going to cover them. So I'm going to put them into, yeah, I'm going to avoid them because the last time I talked about complex numbers, people are like, where are we going to use them anyway? So yeah, if one day you want to use complex numbers in your analysis, you can search. Yeah. Okay. So now I'm going to show you also how do we assign data, so a certain data type to a variable or object. So we call them objects or variables. Okay. How do we do that? So the answer is we use, so answer ANS use, so we have three ways of assignment. So you can use the simple equal, the single equal like this. So I'm using backtick. Backtick is, the touch that is before one. Yes. So you can use the equal sign for assignment. You can also use this. Okay. So that means that send the content that is on the left on the right hand side to the object that is on the left hand side. Send it. It's just like arrow left. Yeah. Or if you are lazy and you are at the end of your code, you wrote a code and then you want to send it into a variable at the end, you can also use this one. So the code that I've just finished writing, send it into a variable named this. That works also. So the commonly used are the first two. The last one I will show you also how we use it later on. Okay. So we should not have spaces in the name of the variable you are defining. If you put any space there, you're going to get in trouble. Like x number is equal to 0. This is going to bring errors because, yeah, you can even see that R is not understanding. You see highlights already. You see that it is underlined. So you must not have spaces in the names like this. And also, a naming should not start with a number. It's not going to work. So R is warning you already. Okay. So you can start with underscore if you want. You can start with anything, but not a number nor a symbol. Like you cannot also start with a symbol. I don't know if this one could work. No, never. Yeah. You see errors like unexpected ampersand character. Okay. So let's now define a numeric or an integer. Define an integer. So you can call it x int, which means so it's not like a general rule or something like that. It's just my way of naming my variables. You can even add your name here if you want. You can say Lema is equal to 0. Yeah, it's not a general rule. You can even remove the underscore if you want. So underscore is allowed. Hyphen is not allowed. Hyphen means x minus int. So if they are not defined, R is going to yell on you. R will be like x is not found. So x is not in the memory. Okay. So if you want to define your variable, be sure that there's no space, no operator in between, your characters. Okay. So my integer, sorry. This is what I'm trying to do. So to define an integer, if you say it should be a whole number, right? Let's say the integer is 5. But if you check the class of x and of int like this, and then you run, it's saying numeric. But now if you want to force x to be an integer, you have to add capital L after 5. Now if you run it, now it is an integer. This, so I don't know if you want to get the right answer, you have to ask those two people. Where are they? It was invented in 1992 by who? They're here. By Ross and Robert. And R is named after their first names. R. So if your name is starting by, I don't know, Jedoni, or so you can maybe invent one. So actually, yeah, this is the way they found to instruct R that this is an integer. Okay, you can say yes, you finish by L to say this is an integer, 50L. This is not 50 liters. It's an it's it's an integer. Okay, yeah. But now if you want to print the value that is in X int, if you want to print it, it will show you 50. The L is disappearing. But the L is just there to force R to understand that this is an integer. Okay? Yeah.
What I was asking,
Yes.
for example,
Mm-hmm.
those who don't know this program in C++,
Mm-hmm. Yes, I understand. I understand the struggle in C++. I understand the struggle in yeah. You start like float X and no here R understands. Yeah. R will just understand that this one is a float, and that is making R also very flexible. Hmm? So now, if you don't put any L, you know that it is going to be just a numeric variable, right? So X num, I think that one is lunch now, or is the code. Mhm. So the class function helps you to identify the data type. Okay. So now, if you don't put L, it's numeric. If it is dot 0 or any other decimal, is still numeric. Okay. So we can also force the conversion of a numeric variable to what? Hmm? To integer. So using so it is as dot family functions. So we have in R those family functions started with as dot. If you do just as dot, they will come. The whole family will appear. Let's say as dot. You see? So as character, if you want to force the conversion into character, as date, as complex, as data frame, as everything. Yeah, as date, as dendrogram. If you want to convert something to a dendrogram, as distance, as double. Yeah, as expression, as formula. If you are running machine learning, you can convert a string into a formula that will be considered to fit your model or something like that. You can also transform something into a function. Yeah, clustering, integer, list. Yeah, a bunch of, yeah, you can even convert into a null. A lot of things. So for us, we are going to use as integer. So create or test. So if it is create, you use as. If you want to test, is dot. You have also this family is dot integer. If you want to check whether it is an integer, okay, yeah. But we are now using the as dot family. So as integer. So if I write 50 plus like a decimal number, what is the expected output? What is the expected output of this? Since we are dealing with integer. Sorry? It will just take the integer part and leave. It is not rounding. That's why I just put 6 on purpose here. Even 5. But it's not going to give you 51. It's just 50. Just gives you the integer part. Like this. Okay. So now if I'm lazy, I don't want to define the variable here, I can send it to a new variable. So now I'm sending it to like force integer. So now I'm forcing the conversion into an integer. I can still check. I can still print it, and I can also check the class of it. So as you can see, it is an integer, and the value is 50. So there's something I mentioned. All our variables are listed in the environment here. Before it was empty, right? Now they are here. The environment is no longer empty. All objects you create will be displayed here with their values. Okay. And even the first one, the first integer is having 50 liter. The L is there because it is an integer, right? Yes. Yeah. Yes. Automatically, L is added to force the understanding in the system that this is an integer. Yeah.
If you want to use a
Back arrow.
just integer.
Yeah. Now it will no longer be on the right hand side. Yeah. Yeah. It will be like this. Now it will be like this. Yeah. So this one means send this quantity into, and this one means that assign. Yeah. But all of them, they mean assign, but assignment when the object is coming after the statement or the code or before. So they're just arrows. So now let me check your understanding. Will this work? A is equal to 1. If I run this, will it work? It is going to work. So we assign 1 to A and we also assign it to B. Yes, it works. And now if you print A, so you can also write print B like this, Command should be separated by semicolon. Okay. Print A and B, their values will be 1, 1. Okay. Yeah. Yes. Yes. Like this. A equal to B equal to 1. Works. The same thing. Yeah. Okay. So now we can define an integer or even force the conversion into an integer. Okay. Is it understood? Then you have 3 minutes to lunch time. Let's go for lunch, and then we can come and define also what is next. Yeah, you are dealing with strings now. Okay, after lunch we are going to carry on with strings. Okay, online. Let's go for lunch. Thank you, Colette. See you in 1 hour. Sharp.
See you. Bye.
Bye. Hey, it's the Colette I know. Why are you not? Why are you not here? Hmm?
Today I have a makeup.
Okay, you should come tomorrow.
Yeah.
All right. See you.
See you. Bye.
Hmm.
For those whom we are here together for the first time, the online
From the variable definitions. Okay. Yeah. So the section name is variables and the data type in R. So those are the possible. Hey, I thought I on it. Yeah, okay, it is okay. Good. Hmm? Can you do right click like this?
It's saying to put it in, click it.
Yeah, run as an administrator. Move the program folder closer to the boot disk.
So move it to C record this.
Yeah.
And then to the
Yes, move it to C. Yeah. So yeah, those are some of the variables or data types we can have in R. So the first one, not the first one, they are not in order. It's not like integer is more important than numeric or no. So we have integers. We can also have numerics. So an integer is also a numeric, okay? And in numeric, you have floats and doubles, and you also have character types. So it's just wording. It's just like strings or alphabets and so and so. So, but strings, they need quotations, okay? And you have booleans, which are logicals, like true and falses. If you want true and false. And we have factors. Factors, this is also a data type that will inform R that we are dealing with categories, like categorical variables, right? And they are very important in some summary tables and also modeling. So if you show R that this is a categorical variable, then the dummy encoding or one-hot encoding will be very, very easy. I don't want to bother you with the one-hot encoding. It's just gamification of a variable. It's yeah, if we reach up to the modeling part, I'm not sure we reach, but it's very important to inform her that this is a categorical variable. Okay. Yeah, we'll also do hypothesis testing. So for medical people like my friend, sometimes we want to know that the group in which we gave drugs, the drug is working more than the group in which they just got the placebo or something like that. So yeah, we need to test those hypotheses. Yes. Yeah. So those are theoretically the variables we'll encounter in R. Practically now, we are going to define them. Okay. So what is an integer? So this is how we define an integer. It's not only 50L like this. It can be 1L, but the L is telling us that this is a whole number. It is an integer. Am I communicating? Yeah. Yes. And this is how we print value. In R, you don't need it. You don't even need the print function. But yeah, if you're coming from Python, print also does it. Sorry, I got disconnected because of my battery. So yeah, I'm back. So if you want to see the value of variable you defined, like x int, can use print or not even use print. You can just write the variable name like this without print. So R is going also to display it. You don't need necessarily to put print. So, and now if you want to know also the class, sometimes people use also the type of x int is going to give you the type of the variable. So sometimes type of can bring another thing, but it's still the same for numeric variables. The class can give you numeric, but the type of can be double or something like that. Yeah. So so we have defined here an integer. We display it, and we can check the class of it or its type. So why am I putting a semicolon here? It's just to prevent us to have another line of code. So you can write everything on one line separated by comma. You can even do this if you want. Only one line of code separated by comma. This also works. If you want to save places, if you compile, it's the same output. Yeah. Is it clear for integer? Can we move to numeric? So numeric is any number that is not in the integer. So as I told you, an integer, if you write it without a nil, is a numeric already. So if you write this is a numeric. If you want a decimal number, it's still a numeric. But now if you do type of, you are going to see a slight change or a slight difference. So let me run, you see. The class of xnum here is numeric, but the type of it is a double. So type of is more precise. So it's a numeric, but double means a float. It's a decimal number. Yeah. Okay. So I also said that from a decimal number, we can also force the conversion into an integer. Means we are just going to consider the integer part. Okay. So instead of taking everything, if you use the as dot integer, we are just going to get 50, the integer part. All right. Yeah, and this is where we stopped. I don't know if you have any question. Otherwise, we can. And those ones are just explanations, assignments. Like you can assign, that single value to A and B. Just like two directions of assignment. So one is assigned to A and 1 at the same time, or this is also the same way of writing it. Both codes are the same. So if you print A and B, you're going to get the same result. But that was just an open parenthesis. So let's close that one, and then we can run. Are you still typing? You have just arrived. How are you going to catch us? Okay. Now you are in person. That's clever. So here, when you also want to check the type of, so no need, right? Because if it is an integer, it will be also integer as up, isn't it? All right, let's define now. What's next? Character. Defining character type, character or string type. Variable. Okay. So if I say RSTR, I am learning R, or anything else. Learning R, programming. Yeah. So we can print it. If it is saved in RSTR, you can print it by just typing the name of the variable. And we can also display class of XSTR, and also if you want the type of Yes. I hope I'm displaying my screen.
See. So what's next?
You're all set. Okay, close. Then you go back to the folder. Here it is, right? Where's the folder?
Oh, I brought it on, right?
Mm-hmm.
The folder is in downloads.
Mm.
I brought the setup on. But
Mm.
I bring it to.
Oh, you could have brought everything. Hmm? Where's the folder? Is this one?
Yeah, I think so. Yeah.
Okay, so to the root.
Okay.
Mm-hmm. Yeah, save it somewhere. Yes, so what is the utility? Did it disappear? Jeez. So the folder utilities, I think, just ran away.
Was it there?
It wasn't?
Mhm.
So let's reopen this one to see. We have utilities here. Yeah, it's here. Utilities. Activity. Is this one?
So once it's done, it will be done.
It will be done. Yeah. Detected. Even if your Windows was not activated, it could do it for you. Yeah.
Okay. Once it's done, it will be done.
It's done, I think.
Oh, it's done. Yeah.
It's saying ending. I don't know if it is
So
done.
I'll tell you it's mission successful.
Yeah, that's good. Yeah, sure.
So how will I know it's working?
Sorry?
How will I know it's working?
Open what?
it.
Yeah.
Okay.
All right. So, yeah. So for integers and character type variables, so the class and type of do not differ. Okay, they're the same. Then this is just defining a string variable, right? So when we'll be loading real data in the system, we'll encounter all those variables in the data columns. So now how do we deal with them is the real problem. How do we, like sometimes when you are in health facilities, some people record men, women as 0 and 1s. Some people also record male and female like this. Some people write it like male, female. How do we harmonize things so that when you want to like calculate the number of female or male participants in that survey or analysis, you can now say, okay, if you encounter, decode it or recode it into. If you see capital M, then it is male. If you see F, then it is female, something like that. Okay? Yeah, this will come later when we'll be dealing with data transformation or data wrangling or data cleaning. Okay. The most known name is data cleaning. Okay. But here we are just showing the types of. Yeah. So the next type of is what? Boolean. Do I need to talk about Booleans? We already know them. It's just like assigning true and false to a variable. But let's do it. Let's define a Boolean. Defining a Boolean. So meaning that if you can say x ball is equal to maybe a result of a checking. If you want to check whether 10 modulus 3 is equal to 0. So what will be the result? What will be stored in bool, x bool? No, bro. It's a Boolean. It should be. All right, let's print it. What is the expected result? We are checking whether the remainder of 10 divided by 3 is 0. Yeah, so the printing will show us false. Okay, and now if you want to check the type of or the class of x bool, so it's logical. Okay. So do check your markdown. This is how we know whether the file is compiling. Check it time to time. If it's not running, means that your script has an error. Okay. And you know, because of one comma or any unnecessary thing like a backtick here, the entire notebook is not going to run. It is altered just because of this thing. But even if you have an error, you want your workbook to be working, you can add an extra. You can say if you encounter any error, then just bypass it. Then it can still be displayed. Okay. Yeah. The X Boolean is double O. But here it's sensitive and also it's not X minus, it's X plus 4. X is also it's not but remove the last three. I will just extend the last three lines. No, it's so you may wonder why are we using this button and we don't use this one. So this one means run everything before this chunk. So if you want to, like you have a setup app and then you want to refresh or reset values in variables, you can now run from app. So it will do the resetting until you reach the last cell. This is also found in Python notebooks. Yeah. Yes. Are you asking whether an R script is saving itself automatically? I think yes, if you have like you have this data cloud, if you have an approach, you can close and still come back on the same thing. Yeah, but if you save, it doesn't take any cost you anything to do Control S. So yeah, this is the trick. When you code, yeah, don't forget to do Control S, but you never know, it can disappear. Okay. Yes, please.
If you can look,
Mhm.
I can't write some word because it's hide.
Mm, what is hidden on your end or here?
In my copy, because you are
Let me check. Where?
trying to write some those codes.
Uh-huh. You have to compile. You have to compile by clicking on the play button. Yes. You are not the one writing. It is compiling.
Yeah.
Yeah, yeah. Yes. If you play it, then if you play it like this, actually it is hitting the console first. You see, it is going to the console, and it is the console now bringing back the message here. Yeah. Yeah. You see, anything you run from here is being interpreted in the console before it goes back to the Markdown. Yeah. So next is complex, right? But I'm just going to define a complex variable and then see the type. That's it. I'm not going to show more about it. No factors. Yeah. So even for the factors, I'm not going to cover it here. It's when we'll be importing now a real data set, or maybe an example data set. I will discuss the factor with you. Yes. Dates. Yeah. So dates, date and time variables. So if you remember, in the header we had like current date. So x date is equal to sys dot date. So this is and now if you say x date, means that you are displaying it. It is going to if you need date and time, so you can say x dt is equal to sys time. Yeah. Huh? Sys time. And that one, if you display it, you are going to now 2026 August 8th. And now it is the current time. If you check your watch, it's exactly 14:42. Yeah. And I think I clicked play when it was 18, on the 18th second, and then Central African time. Okay. Oh, yeah, it's going to change. So let me display DT here. So anytime I run, now it is 55th second, 58th second, 59th, 43:01. Yeah. Yes. Now, if I want to check the class of X, this one, and also the class of X date. So both of them. So this one is POSIX means that you have date, time, and even the zone. Okay. The zone is this one. The time zone, TZ. Time zone is CAT, Central African Time. So you have the date, time. That's why it is having now the class POSIX. Okay. Yeah. So it has two classes. All right. And the second one is just date, because we are having just year, month, and day. Right. So sometimes I'm going to explain something in some systems. So dates come in different formats. Formats such as, so you have things like this: February 02, 2024, things like that. Or you can have day coming before month. Okay. 08 2026, or you can have also month coming before, so 08 02 2026. And etc. So it's the same as having male and female recorded using numbers or maybe initials or full word or capital. Now we need also to harmonize dates so that we can also have like trend lines if you're analyzing time series. All right. So we need to harmonize them into a format that are, yeah, I'm coming, understands. Mm-hmm. Hmm? What? So I define two variables. So let me pick one. What's good? It's not. You have to print it. So printing it and just writing the variable name. Oh, yeah. This. Where did I print it? I think I got rid of that line. Sorry. You can use print or not use it. It's up to you. Okay. Fabrice, it's all good? Fabrice, it's good, right? Okay. All right. Yeah. So the first display is for the POSIX city. So time, date, time, and time zone. And this one is just date. Okay, and this is the class of the first one, and the second one is the class of the date only. Yeah. Are we together? It will get very interesting when we will now use those knowledge on real data when it comes to analysis. Okay. So XDT. No, the first one is X days, and the second one is X. So if you don't define it, then R will complain. So change the second line here to XDT. Yeah. Yes.
Now, X meaning today.
No, this means display what is in the display what is in the Actually, if you want to understand it, it means print the value that is stored in DT. Yeah, print the value of XDT. Yeah, even here. This one even means print the value of X date. So it is not necessary to even put print. R will understand. Yeah. Yes, please. Why are we getting those codes back? It's because we didn't tell R to omit them in the rendering of the document. Yeah, if you say echo is false, you don't get any code in the final document. Yeah. So if you say, is it the question or I didn't answer the question? That was the question, right? Okay. Yeah, because I told you that in your final document, the reader do not want necessarily to see your code unless you are defining maybe a practical document so that someone can check the code and then the result. Yeah, if echo is false, then only the output is being shown. Yes. Yes. And now you can even say jump this chunk, don't run it. Now, instead of echo, you say eval, don't evaluate this one. Eval is false, skip that chunk and go to the other one. Yes. Yeah. So it's not part of it. Yeah. So now, yeah, evaluation is not printed, but the code is printed. But now if you combine evaluation and echo at the same time, I think the content of that chunk you just see the title. Yeah, only the title is appearing because you said don't echo it and don't even run it. So no output is coming because it is not being run. Is that okay? Good. So for now on, we are not building any, but I can put them somewhere. Let me just put them as comments. Yeah. So this is for later. Okay. Now I think we covered most of needed variables or data types. Okay. So now a data type is the type of data we can have, be it integer, numeric, character, or Boolean, or another one, which is date. Now, a variable is the container only. You save the variable in something. Yeah? And that's it. Now, we also have other data types. But we call them, instead of data type, we call them data structure. Data structures. So the data structures we can have a vector, okay, in R. We can have a list. And then even before list, we can have arrays. So those ones, they are from 1 to n dimension, okay? Okay, so R also can handle multi-dimension data. Okay, it's not only 1 and 2D. So a vector is just a 1D, so 1 dimension. An array can go from 1 dimension to n. So a list can handle multi type data. So multi-type because in a list you can have integers, you can have booleans, you can have anything you want. Okay. And the big boss is the data frame. So a list is just like it's like a dictionary in Python. If you will ever use Python, this is not far from a dictionary. Okay. So a data frame is now a tabular. Matrices after vector. So yeah, that's it. So vectors, matrices, arrays, lists, and data frames. So for data frames, we have what we call inbuilt data frames, and we will be importing data from what? External sources. Like files, servers. So servers we can have SQL servers, Postgres server. And if time allows, we can also do data web scraping. Web scraping means one can, if you want to like write a script that will get into websites to fetch data. Like some people are interested in collecting house prices or land prices in Rwanda or car prices. You can write scripts that will enter websites and then find the location of the flat or maybe the land, and then get the price if it does exist there. And if you're able to do such a thing, you can also come up with something that will help people to, if you take Kigali, for instance, you can be informed about maybe the average land price in maybe yeah, a specific sector or a specific village. So yeah, I think such a thing is not yet done in Rwanda. So yeah, if you are thinking of a future project, you can build maybe a dashboard displaying all those information. Hello. Yeah, I'm busy lecturing. Yes. 1 second. Okay. Oh no, so you can also have like S3 buckets. Yeah, those ones you have to have money to be able to set one. And yes, so it's Amazon sometimes products or Google or Microsoft buckets, and you need money to have your account there. And whatever you do there, you have to pay them money. So I think we mostly deal with files and local servers. Okay. We can from R send data into our local server, and then maybe use some few SQL queries. I don't know if it will be out of scope, but yeah, we'll try. We'll try. You know, you have to touch on many basics to be able to handle situations. Yeah. So, what is now a vector, and how do we define a vector? We already know it when I was talking about checking whether one is in. Okay, just leave it. Thank you. So, yeah, first point under this section. So first subsection under this one is, yeah, what is a vector? So what is a vector? It's not the vector with magnitude and the direction. It's not that one in mathematics. It's just a collection of what? So a vector is a collection of what? Objects of the same type. This is very, very important. Let me even put it in bold. So how do we bold things in R? Is double star before, double star after. This is bolding. Bolding, bold. Yeah, bold. Mettre en gras. Bold. So if you just do single, means that you are doing what? Italic, or this is italic and this is bolded. So a vector is a collection of objects of the same type. So why am I bolding the same type? If you mix data types, you are going to see how the vector will behave. Okay. So let's add a new chunk. So how do we define an empty vector?
It's just this. This is how you define an empty vector. It's C with nothing in it. Okay. You may also use it's also the same as X empty. You can also use numeric like this. This is an empty numeric vector. If you want to be specific, this is an empty numeric vector. I think maybe you have to add a 0 there. I don't know. Yeah, it's all good. Yes.
C for character.
Hmm?
C for character.
No, C for combine. If you want to know why is C for combine, you can do question mark C. And then it will open the help. So C is coming from the base package. So base package means when you install R, it is already there. So it stands for combining. Yeah, this one. What is the definition? Yeah, which combines its arguments. Yeah.
Because of the numeric.
Yeah, if you want to define a numeric variable, it's like this. So the first one will give you a null because there's nothing there. It can handle numeric any type. But if you want to be specific, like I want to define a numeric empty variable, this is this one. Okay, this one is any type of data. Okay, yeah. So any function that is in R, you can check the documentation of it using a question mark, the function name. Yeah, in Python you can put question mark before or after, but in R it's just before. Okay. Are we together? Good. So, so we can manually enter values into yeah, if you want to define a vector like this, x vect, you can say, yeah, you put any number there. This is manual way of defining a vector. Just enter numbers. Yeah. So this is already a vector. So what's the class of x vec? So since we are having objects of the same type, so the class of vect, if they are all numeric variables, it will be the class of the unique class of all of them. Okay, so it's numeric. If you use type of is double. Just like, yeah, it is considering like a single element. Okay. Yeah. Are we together? I see. I still typing. So type any number. They should not be exactly what I have here. So type random numbers. You are not forced to have the same length also. So if I want to check how many elements are in my vector here, how do I do that? You know it. That's an English word. Never. Why are you avoiding the word length? Yes. And everything that you imagine in English is a function in R. Even count is a function in R. Yeah? So now count is when you want to count categories. Like how many times 3 is appearing maybe in the vector. But it's not count, it's table. So the length of x vec will give us what? Information about how many elements do we have in X. So here it is saying that X is having 10 elements. Okay? So earlier I mentioned automated reporting, right? You can use this one. You know, you can call it maybe xlen, like this. You can define a variable that will now capture the number of elements in xvec. And now come down here and use it in wording. Like our vector, right? Our vector vector x what? Yeah, x vect has, and now you want to put that number in the wording. When you compile, it appears in the document. So you use the R like this, and you just write something that can be interpreted by x by R. So this exact thing is just put in front of R and in two backticks, and then you can just write elements, and you will see the magic. So the backtick, the touch that is before number one. Yeah. So now if you go ahead and knit your document, you will see what I was talking about. So check here. So our vector x vect has 10 elements. So how did it get the 10 elements? It is because I instructed it in the code that run, in that wording, run and display the value of the variable x len. It's here. This is where automation is coming from. If I add extra numbers, like if I add more, 9.0, 7.6, 3.2, for instance. If I render again, the information will change. Now it has 13 elements. Okay, so as data is coming in, the report will also adapt. Okay, yeah. Okay. So when we talk about vectors, there is also something we call sequences. So those are numbers we can generate, and the end result is a vector. Okay. So sequences. So if you want to generate numbers between 0 and 1, yeah, you can use the function seek, S-E-K. So it's sequence generation. You can see the display here. So generate regular sequences. So if you ever heard about arithmetic sequences, okay? So between 0 and 1, so the sequence from where to where. So you can say start from 0 and to 1, and you can say by 0.01. So those are numbers which are between 0 and 1. See how many numbers you have. And the more you reduce the window, the more you'll be having. So this is 1,000 already. Just between 0 and 1. That's why they say that the set of what? Set of real numbers is infinity. Yeah. Has infinite number of elements. Because even between 0 and 1, you can have, yes. By is actually you specify the common difference. Yeah, the interval. Like this is 0. If you add now this by, it will become 0.01. And to this, if you add this by again, it's 0.02. To this, if you add, yeah, this is just the window, or we call it the interval. And the real name in mathematics is common difference. Yeah. So this is just an arithmetic sequence with common difference equal to 0.01. So en français, c'est une suite arithmétique de raisons 0,001. Une suite arithmétique. So we can also send it into assign it to a variable x sec is equal to, so that it won't display thousands of data points here. So it's just silent. So if you want, we can also do something very interesting from -1 to 1. And I'm going to show you why. So you say that when you have a function f of x, you say that a function f of x, you run away from mathematics. Now you're going to do mathematics. So this function has what? It's like a bell, but turned upside down. Yeah? Non, c'est pas une équation, c'est une fonction quadratique. Yeah, it's a quadratic function, and it's like this. Yeah, it's just like a cup or a bowl. Yeah. And now if I define a certain y sec is equal to these numbers squared, okay, I just have to square everything. So a vector, if you square a vector, is each point that is having now the square. It will be raised to the power 2. All right. I just want to show you that if you plot x and y, so we can do x sec. That's an example, but we will have more plotting later. X. So y is the ordinate, or x the y-axis, and x sec will be in the x-axis. So if I run this, you see the evidence, right? Yeah. Huh? It's hard? No, it's not. And this is because we have like 1,000 points. That's why they are overlapping. But if you reduce the window, you are going to see. So now we have how many? You see, it is now becoming more clear. if you remove 1 0 again, yeah. Actually, it was not a line, it's just points. Yeah. But if this tilde is, if you don't like the tilde, you can also say X. So send it into the X axis and Y is Y axis. This is also the same result. So don't be afraid. Hmm?
Line 115, that line of y underscore sec
Mm-hmm.
is equal to x, those multiplication,
Mhm.
2 times y.
It's the power. I'm just mimicking the function you see up there. So X is the input in the function, is a variable, and the Y now is the image of X by F. Hmm? So remember, we have like two operators for power. It's either this one or this one. And for those who were asking what is LaTeX, this is actually a LaTeX code. It's not an R code. This is how scientists write their documents. And when you compile, it becomes a document. If you can give me 1 second, I can show you the type of document that are generated from. So if you go to overleaf, let me show you some of my projects on which I worked on. So if you want to publish an article and even any review, if you want to publish a paper, you can write it here. You can write mathematics and you write everything. So let me just let me just open this one. So actually, it is just a bunch of. Do I need to have access? No, I don't need to. So those are just codes, later codes. You see, you write as if you were in R, and then you can cite papers. You can include graphics. Graphic can be somewhere in the working directory. And if you compile, you get a document that is ready to be published. Let me just. You see, this is a paper. And it is just from a bunch of codes. Yeah. So this is one of my students who was working on it, and I supervised her. And yeah, this is a paper with anything you can think of. You can include graphics. You can include mathematics. Let me show you the mathematical part. Yeah. So you have. I know we have researchers here. As doctor, you are a researcher, so maybe you will need it one day. Yeah. So you can write mathematics easily. You can include graphics and anything that you want. And yeah. Huh? And those are applied mathematics. No, it's applied. Yeah. only applied mathematics. And then later on, you can now put the results. You see, results, and those results, they're coming from R. Those are outputs from R. Yeah, they're from R. You just take the picture, put it in your project, and then you call it. It's displayed here. So yeah, just to tell you that we can do a lot with R. Yes. So those are LaTeX codes, and R can handle LaTeX codes. And if when you are rendering, it is also like calling LaTeX in the backend to display those formulas. Okay. Yes. So don't be afraid by this plotting. You are going to plot many things. Yeah. Yeah. And plotting, always you have to map. Where is Y in the data, and where is X? All right. Yeah. Is this clear? We can move on with something else. You have a question? Ask questions. Yes.
That's clear, I've understood.
But if you don't understand, you also ask. You can take me back. Please take me back whenever you feel like you are lost. Otherwise, you'll be lost forever. Please. Uh-huh. So the delimiter you use here is not the right one. Yes, this is the backtick. Open and then close it. Yeah. You see, he could have stayed silent, and then we never discover what is the problem. So if you don't ask questions, neither me nor my co-facilitators will be able to assist you. So please ask questions. Stop us whenever you feel like you are lost. Please. Yes. And sometimes, the message is coming from the air. So the object is not from. So it means that you didn't find the extent. And then we are going to define Now what you are checking is how many elements it has. Yeah, not exactly. No. Yeah. Okay. Now this is normally you see? Do you understand the So please, if you don't stop me, if you don't ask questions, please, you'll be lost forever. So I beg you. And we don't need dropouts. Capacity building is capacity building. You have to get the capacity. Yeah? Yeah. Quoi qu'il en soit, vous devez acquérir cette capacité. Yeah, this is just simple plotting. Later on, we'll be adding colors. We can add the plot name. You can even edit this. Because, yeah, we can edit this one because it's not looking good. Yeah, we'll customize everything later on when we get to visualization. Okay? Now, I was just showing something. Like, this function, actually, it is a bell shape, right? Yeah, like a concave. Yeah, convex is this concave. Yeah. So now we have vectors. We can also generate random vectors. Okay, random vectors. So vectors generated randomly. So think of who have ever like played the dice game. Dice, le jeu de dés, le Ludo. 6. We do like this 6. Or you take the dice, you throw it, and then you can record the number. We can mimic it here. We can mimic the dice game. Okay. So what do you do? We just use the sample function. So if you just use sample 6, it has 6 faces. So we have 1, 2, 3. So it means that you are sampling from 1 to 6. If you just put 6, so it will just choose by default one number. Okay. So if you do this and you print what is in X dice. No, I said something wrong. It is displaying like 6 numbers. So it means that when you threw the dice for the first time, the face that showed is 2. Then followed by, the second trial is the face 4, who has 4 dots. Then if your target is to get 6, so for the 3rd time you won. And then 4th time lost, 6th time you lost, and 6th time you lost. And this is at random. Whenever you be clicking on it, those numbers will change. Yeah, if you click play, it is going to change. Yeah. But now, if you want to have like only one output, yeah. Yes, please. Okay. So you specify the size. Size is 1. So it means that instead of getting 6 numbers, 6 trials, you just get 1 at a time. Okay. So if I tried the first time, this is my first time, I got 4. I tried the second time, 5. Third time, 1. Fourth time, 4. And so and so. Yeah? So I can ask you in an exercise, write a for loop to generate 1,000 trials using a dice. So this is our dice. So I can say, when we'll be covering the for loops. So for 1 to 1,000, generate now these numbers. And then you save them in a vector. Yeah. Okay. Or instead of even using a for loop, we can even have it here. You can say size is, now if you have size, the size should be maximum 6 because you have 6 spaces. But if you now want to have like 1,000 trials, R is going to yell on you. You'll be like, no, I cannot do it because by default, the replace is false. Does it trigger something? Have you encountered that thing? Like, who did probability in high school? Huh? You never did probability? You did. You did. Yeah. Tirage avec remise. Yeah. So this is sans remise, but avec remise means that you have to, if you have a bug, yeah, you take, and then you can put it back to take again, so that you can have up to 1,000 trials. Yeah. So you have to add an argument here. Replace is equal to true. So drawing by replacement. Now you can have your 1,000 trials. So the person spent a whole day tossing a dice 1,000 times, and this is the outcome. Now my question to you, okay, you don't have the answer. If I want to count how many times we have the number 6 in this bunch of numbers, if I want to count how many times 6 is appearing in this sequence, how do I do that? Good answer. We use R. Yes. So you can test. Okay? You can test. This is a testing. What is the answer of this? It will test 1 if 1 is equal to 6. If it is not, you will have false. It will check for this one. If it is not 6, it will be a false. This one will be true. Yeah? And then false, 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 false. True, false, false, true, and so on and so forth. So you will have also a vector of Booleans. Now, if you have a vector of Booleans, how can I identify quantify now the number of 6? Huh? No, it is in front of you. You said it. I gave you my sweets. Yes. So now, if you don't tell me, I will take two things from you. So if false is 0 and true is 1, how can I get the number of 6 in this sequence? If false is 0 and true is 1, we agreed in the morning that false is 0 and true is 1. So now, how am I going to get the exact count of 6 in X dice? You just sum them. If you write the function sum on it, on this one, we have 160. So 6 is appearing 160 times in this sequence. If you want to check for 2, around 146. You want to check for 4. 181. Yeah.
So it doesn't count.
Huh?
It cannot count. The other right cannot count.
It counts. It counts very well.
If you don't have true or false,
You can also use the function table.
let's assume you have A and D.
Mm-hmm.
So how could you know how no, sorry,
Mm.
C and D?
Mm-hmm.
How could you know the number of C? You have to count.
So the elements that verify this condition, they are 181. Means that you have 181 4, and the other ones are not 4. So you use the function table. This is a count function for us. You are not. You are not lost. You are losing yourself, but you are not lost.
You know the machine or R knows false is 0.
Uh-huh.
True is 1.
Mm-hmm.
So if we change those characters or strings
Mm.
by name.
Okay, let me not test and just do table of the original variable. Is it what you want? So it means that 1 is appearing 172 times, 2 is appearing 146 times, 3 172 times. And does it answer your question now? Are you back? Or are you still lost?
I understand. But okay, let's call the 5 one.
Hmm?
5.
5?
Yeah.
No, now it is bringing the count for each of the categories. But if you want to be specific,
Only 5.
if you need 5, that's going to be complicated. So what you are going to do, let me do this. Now you can also filter values in a vector. You can say from this vector, I want to. So now you are going far. You know, you are always ahead of us. Eh? You want, you see. So you want to display only. Yes. So now you are doing what we call what? Slicing or filtering. So you filter X dice that obey this condition. So you are going to have only 5. Hmm? Yeah. And now how do you count them? No. How did we count the number of elements in a vector? Come on. Length. So now I run the whole thing. You see, 5 has 174. And now the last display is also 174. This is specific to 5. But anytime I click on the play button, things are going to change. So how do we fix the randomness so that when I run something here, you get the same thing over there? We are going to fix the randomness by using this function set.seed and just write 1, 2, 3. If all of us have the set.seed 1, 2, 3, the same seed, then the randomness is fixed for all of us. So you get the same result. If you write the same code. Can you try? Oh, I made you lost. Yeah, actually, this is just the basics. You will see the importance of it when you do importing data and you do the analysis. But if you don't know the basics, it will be hard to even do one analysis. Okay? Yeah. So table brings the count by category, right? So counts the number 5. So counts how many times 5 appears in the sequence. So I'm going to answer your question again. If you, instead of having a numeric vector, now simulate maybe a vector called gender, where we'll be having male and female, and then count the number of male in the sequence and the number of females in the sequence. Are you done here? What I mean by done is the code is working and you understand what you wrote. If you don't understand, then you are just writing. Please, if you don't understand the logic, please stop me. Yeah. Okay, let's now simulate a vector of gender. So vector of gender through simulation. So when you are doing sometimes scientific work, you need simulations. Sometimes you cannot get data, real data. So the only thing you can do is simulate data and then apply your algorithms on. And yeah, that's why I'm showing also this. So let me call it gender is equal to, so we are still to use the sample function. And now the vector to pick from is male and female. So I'm just defining a vector of gender. So we have only male and female. Now, if I want to simulate it like 1,000 times, I have to specify the size, right? Size is 1,000. And since I cannot go beyond 1,000 with replace being false by default, then I have to assign true to replace in as an argument. Now you can also have another argument, which is probability. So if probability is, if you don't assign anything to probability, means that you want to have like half-half, 50-50. But if you say, okay, I want around 30% of male and 60% of female, so it is 0.3 and 0.6, and 70% of female. All right. So I'm breaking lines because I don't want to, just go and it will be hard to read. So count the number of males and females in the data. And assign it to a new variable named gender counts. Yeah, small exercise, small danger. So count the number of males and females in the data and assign it to a new variable named gender counts. So maybe numbers would take S because you have two numbers, number of males and also the number of females in the data. Hmm?
Can you call the variable from the previous chunk to another one?
It's very possible. Try it before. Like, yes, you can. Like if I put X, this is the first one, right?
Yeah.
It's going to appear. It's here. They are communicating. It's the same environment, so they communicate.
The small c.
Mm-hmm.
C, sample brackets, C.
Yeah, I'm just creating a vector of two categories, male and female. So we are going to use this vector now to loop it, so that we get 100 times male or female randomly. And now we are going to count how many male and female we have in the data we simulated. It's just data simulation. Yeah. So this is a vector, character vector of two modalities or two categories, male and female.
And the C
is combining.
Yeah.
Combine. Yes. Yeah. It's small c. If you put capital C, it's not going to work. Just a small c. Yeah. Is it working on your end? Is it working? If it is not working, call me, because if you don't react, I will assume that everything is okay, while it is not. So how do we fix the randomness? Who can remind me that? Set seed. Yeah, he remembered seed only, so it's setting the seed. So 1, 2, 3. So we decide to have 1, 2, 3 for simplicity, but if you want, you can do 7, 9, 10, or even 0.05, or even 50. It depends. Okay, but we have to have the same seed, so that we have the same counts, and so and so. So which function do we use to have those counts? Table. Please, there is no wrong answer. Answer the way you want. If it is wrong, I will say no, it's not. But if you remain silent, it's not an interactive class. You have the answer, you said it. You say it. Even if it is not true, we are in the process of learning.
It doesn't work.
The simulation?
Okay.
You see, it's not semicolon, it's just comma. Yes. No, you created a new problem. Parentheses. Yeah. You every argument is after yes. No. At the end we don't have to. Close the parentheses of sample. Open the parentheses of sample. You see, I close two parentheses. This one is the parentheses of the probabilities. So it means 30% for male, 70% for female. So I close for this C and then close the global one for sample. If you don't close everything, then it is not going to run. Yes. Working? Mhm. Yeah, probability, you know, R is highly case sensitive. Probability is not with capital P, it's just small p. Small? Yes. This is the only error you have now. Is it running? Yeah. If there's no error, means it's running. It is running. No, me too. I don't get any error, and there's no output. Yeah. So everything is saved here. That's why you see no output. So if you want to see the output, you have to just print gender like this. So this is your vector of. So if you are participating in a survey, it means that the first person you interviewed in your survey was a female, followed by a male, and then a female, and then a male. C'est comme ça. Donc la première personne que vous avez interviewée était une fille, une femme. So now, how do we count the number of male and female in this vector? Which function should we use, if you remember? Huh?
Table, maybe.
Table. How sure are you? 100% or 50%?
90%.
100%. This is what 90%. I want.
90%.
So the table gives you the counts by category. I already said it. Yes. So now you have like 705 female in the data and 295 male in the data. Okay? Yes. Yes, please.
That's why we're having different results.
So when you run, that's run. Click on play.
Results are different.
Yeah, it's different. No, it should not be different. So it is running. That's why you don't get any error. And then if you write gender, means that print now means that run again. Now it is running. So if you now write table gender, as the way I print it, yeah, now you get the counts. Yeah. So have you added this set.seed 1, 2, 3? If you don't add that, we are going to have different results. Let me check your. The danger is, you see what he did. Look, what he did the simulation up and then added a new chunk here, and no, it doesn't work. So the randomness, there is no randomness here. But the randomness is up. Yeah. So now, what does the exercise say?
So from where do you get now the number 1, 2, 3?
So now you have this the set seed on top of gender is equal to sample. Did you write this last statement? So you must get 705. Do you get it? Yeah, we run again. If you don't run, you have it.
You say, but I'm asking, where you get now the 123?
Oh, we are fixing the randomness. If you write 0, so I have to inform you that now my seed is 0. If you put 0 there, you have the same thing. So we are, random numbers in our computers, they are not random. Yes. So I have to run 2. You have to run it together. So now the seed is.
If I have a 0, I get now 6. Yeah, 69.
Yeah. So now, are you convinced or you need explanations? So where is the 0 coming from? The set seed function just need where the randomness should start from. This is the seed. So random numbers in computers are not actually random. They are pseudo random numbers. There is a big random generated. This is also a course, random generated numbers.
Put in 2, for example.
Yes, if you put 2, then you get a different result from me. So they are not random, they're pseudo numbers, random numbers. And every random number in a computer has a seed. So 0, it will be all of us having 0. Otherwise, your result will be different from mine. Yeah. So now if you change to 2, so you're commanding us to also change our seed to 2, right? Yeah, if it is 0, then we are on the same page. So there is no rule about this. It's just for reproducibility. Yes. Can we go out and run a bit? So this is just for reproducibility. That's it. I have to charge my phone also. Okay, 5 minutes. So the rest of the exercise is saying from the to do. So since you can determine the counts, of male and females, right? Assign that result now into a new variable named what? So you know how to assign, right? Yeah. So these are to do, and then use now this variable to generate graphics now, a bar and a pie plot. Okay. So for the bar plot, you use the function bar plot, and for the pie plot, you use the function pie. Okay. Please do. It's just a matter of taking the variable and put it in those two functions, and you see the results. Yeah. But if you don't assign it, then R is going to ask you what is exactly gender counts. So where is gender counts coming from? From an assignment you have to do. Can I repeat it in French? Or you got it? Hein? Yeah. Donc, le reste de l'exercice dit, il faut maintenant affecter le résultat que vous avez ici. Ce résultat vous donne le nombre de femmes et des hommes dans les données. Donc, maintenant, il faut affecter ce résultat à gender counts. Vous savez comment connecter les deux. Ça, c'est une nouvelle variable qu'il faut créer. Maintenant, vous donnez cette valeur-là à cette nouvelle variable. Après, vous l'utilisez dans les deux fonctions. Ça, c'est pour générer le diagramme en bas. Et la seconde fonction, c'est pour générer le diagramme circulaire. Ou le diagramme en camembert, comme on l'appelle. Oui. Voilà. Donc, il faut juste, si vous avez déjà fait l'affectation, vous prenez ça, vous mettez dans les deux fonctions. Et là, c'est des lignes de commande. Yeah, sorry. We all have to be on the same page. Is it working? Good? Yeah. That's really nice. Yes. Like that. Yay! Bravo. Very good. Yes. Okay. So to make our lives not very complicated or not miserable, I'm going to skip matrices and arrays because if you want to do matrix calculations, it will be, yeah, if you didn't do algebra before, it will be very bad. Linear algebra. You are the only one who did linear algebra. Yeah, l'algèbre linéaire, ouais. Hein? C'est pas si difficile, mais ce n'est même pas difficile. Non. Si vous pouvez utiliser les nombres pour constituer la matrice en R, multiplier, soustraire, additionner les matrices, c'est très facile. Oui. Bon, on peut couvrir ça. On peut le faire. I'm not going to skip matrices, but maybe arrays. Okay? Since we are always, we'll be dealing with 2D and 1D. So it's a must to cover matrix and vectors. So for arrays, I'm going to jump. Okay? Yeah. So discuss also, please. If you are able to do something, you become automatically a tutor or a facilitator. So you are a facilitator. Wow. So this is still our dashboard. This is very understand that you get to test with numbers, percentages. Yeah. Yes. So yeah, let's give ourselves a few times so that everyone can understand. It's background. Yeah. I am mixing Python. I know you love Python more than R. Yeah, the instructions are here. Use the function pi and then you just throw the counts in there.
Yes.
I don't know if you are.
Yes, already done even.
Already done.
Yes.
Very good.
Screenshot. Okay, let me take it.
Can we run the solution? Or is someone still struggling with the assignment or the small exercise? C'est bon? Okay. Sir, excuse me. Is it good on your end? It's not? Okay, so you are able to get the counts, right? You have to assign this result to gender counts. No. So, yeah, this quantity should be assigned to a variable name called gender counts. So how do you do the assignment? You just have to write gender counts, right? And then it's equal to the table of. This is what the to-do is saying. So once you get this variable, now you can throw it in the document. So you don't have to repeat this one. You can delete this. Yeah, gender concepts. That's what. You should not have like spaces. Counts. The variable name is data. So this should have as a value table of gender. Yeah. You don't need to no shift. Don't hit shift. Just hit it. Okay. Here, shift and this. And hyphen. Off means just now you take it to the level of gender. This is a new variable you defined, right? Can you copy it? No, that's the variable. So what does it say? Oh, that's what I was avoiding. What I want to do to avoid. Like now the chunk does not have any definition. If you check now, so you can do the same for pi. Just use pi and then put the counts. Is it okay? So under the pi plot, you can also use under the bar, you can add a new line. But where are you adding a new line? No. The limiter should always be below. No. Not pi and then check the general counts. Parenthesis is a function. Counts. Run the whole thing, run the chunk. Big one. So if you scroll down, you're going to see your two plots. Okay, let's write the solution a little quick. So this is the new variable name, right? You just copy it, and yeah, for me, I can copy. And this is the assignment. The to-do is done. Okay. How do we do the bar plots? I have the function already. I just copy and paste, and I have gender counts. And for the pi plot, it's pi gender counts. Now I can run the whole thing. Yeah. Okay. So if you want to deal with colors here, if you say so the first modality here is female. So if you want to specify colors, so I know female, they like pink colors. So let's say this is pink, and for male is navy blue, something like that. So now if you want to change colors, by default you have white and why is it not working? I didn't specify color. Yes. And that also works for the bar plots. You can copy the colors and add them as argument here. It is for the pi, and this for the bar. No, this the first one was pi bar, and this is the pi plot. So when it comes to colors, if you don't know colors, you can just use color function like this. It will display all colors that are existing in the world. So you can pick from the vector of colors. So use color names. Why is color? Okay, it's American name. Colors. But this must be British. I don't know. So we are already doing data analysis without knowing. So when you import data, you can just isolate if there is a column of data. You can just isolate it and then have the same. Yeah. So data is coming with columns, and all columns are vectors. Then we are already doing data analysis and analytics. All right. So from tomorrow we can import files, data from files, and then start cleaning, start analyzing, and doing summary tables. Yeah. So if you don't come tomorrow, you are going to lose. Please, tomorrow everyone should be there, and then invite even your neighbors so they can enroll. Yeah. All right. So I know people are tired, but I feel like adding a few things. So yes, please. All right, that's a good one. He wants to have like a beautiful, like good-looking clothes already. Yeah, I can do that. So you can say if you want a title, yeah, a title to your plot. The title comes from the main argument. So main, title, and subtitle for the plot. Okay. So main count by gender. So you check whether it is good looking already. Yeah, so it has added count by gender. So female and male, they are well written. So no need to add an extra thing, right? Yeah. But if you want, you can complicate things. You can just say, on my X label, I want to have gender, and on the Y label, I want to have counts, or count. So if I run it, so you are going to see the title, the X label, and the Y label. Okay? Yeah. And sometimes people want horizontal instead of a vertical bar. You can still use the horizontal is equal to true, but now it is going to change things. When you say horizontal is true, now you have to think of where exactly the X label and Y label should be. So this should come here, and this one goes there. Yeah, I didn't want to touch on those arguments, but since the question is coming. Okay. So if you're done with everything you can print, we can call it a day. So we are done for today. Benjamin, I'm going to send sample data sets. So actually, I simulated them from, I use clothes to simulate them. So they may look genuine, but they are not, this is just fake data for our examples from tomorrow. Okay. So I will share with you and then you share to the group. Yeah. Yeah. So basically you have like climate data, and then you have, yeah, climate data. So you have also data about patients. You see the problems you have in the data now. From tomorrow we are going to do data harmonization. You have missing values, how to deal with missing values. You know, dates coming from various systems. You have to harmonize dates and so and so. So you have things to do until we get into the dashboard. Even the dashboard should be set using these data sources. So we have many files. Okay. So this one is about student performance. Okay. We have, yeah, and then we also touch on trade. So yeah, we have many things to cover. So all those data files will be shared with you, and yeah. All right. Thanks a lot for your patience and your attention. There's no other question. Last one. This is my invitation. So parentheses. Yeah, remove the parentheses. Yes. How did you? What does it? Remove 1%. 9%. No way.